This is from Neet 2020. Two particles of mass 5 kg and 10 kg respectively are attached to two ends of a rigid rod of length 1 meter with negligible mass. The center of mass of the system from the 5 kg particle is nearly at distance of. This is very straightforward question. There are two particles. Okay. So use our formula XCM. First particle has mass 5 kg. Okay, let me write it. M1x1 plus M2x2 divided by M1 plus M2. And if you are asked, okay, if you are asked what is the center of mass from the first point, then x1 becomes what? It becomes 0. Then directly you don't have to write this also. It is M2x2 divided by M1 plus M2. Okay. So here it's the same case. It is 5 times 0. Okay, because you are asked center of mass from 5 kg mass. So 5 times 0 plus M2 is 10 kg times x2. So rod is of length 1 meters. Okay, so position of M1 is 0. Position of second particle, which is at other end, will be what? It is 1 meter, right? So it is 10 times 1 divided by, it is 5 plus 10. M1 is 5, M2 is 10. So this is 15. So 10 divided by 15 is how much? 2 by 3. 2 by 3 is how much? 0.66. 0.66, right? Or you can say 0.67 meters. Okay, that is in centimeters, 67 centimeters. So this is the answer. Let's see next one. Three masses are placed on x-axis. 300 gram. Oh, sorry. Three masses are placed on x-axis. 300 gram at origin, 500 gram at 40 centimeter, and 400 gram at x equal to 70 centimeters. The distance of center of mass from origin is, again, similar and straightforward question. Okay. So XCM is M1x1 plus M2x2 plus whatever number of particles are there, M3x3 divided by M1 plus M2 plus M3, and it's equal to, so for first one it's 0 because it is at the origin. Second one, mass is 500 gram multiplied by 40 centimeters, plus third one, the mass is 400 grams, right? 400 grams at 70 centimeters, and divided by, we have 300 plus 500 plus 400. We could drop the zeros, right? Because they will just get cancelled out. Okay. So it is 5 times 40. How much? 200 plus 70 times 4. 280. Okay, 280 divided by in denominator we have 300 plus 500, and I'm just neglecting the zeros. Okay, so it is 3 plus 5 plus 4. So it is 5 plus 3 is 8 plus 4. How much? 12. So it is 480 divided by 12. Tell me. Okay, good. Option A. 40 centimeters is the answer, right? Two bodies of mass 1 kg and 3 kg have position vectors. These are position vectors respectively. The center of mass of the system has a position vector. This is straightforward. Okay. So we have discussed the position vector of center of mass. It is what? Sum of position vectors. I mean, it's m1 r1 bar plus m2 r2 bar divided by m plus m2. right? How much is m1? It's 1. 1 times position vector of first particle. I cap plus 2j cap plus k cap plus 3 times the position vector of second particle. So it is minus 3 I cap minus 2j cap plus k cap divided by m1 plus m2 is 1 plus 3, it's 4. Okay. So now 1 I cap, so minus 3 times 3. Okay, so minus 9 plus 1. How much? Minus 8. Okay, so minus 8 I cap plus 2, and this is minus 6. Okay, 3 times minus 2, minus 6. So it's minus 4. So minus 4 j cap, and it is 1, and 3 times 1 is 3. 3 plus 1, 4. 4 k cap divided by 4. So that is minus 2, minus 1, 1. Okay, minus 2 I cap minus j cap is k cap, right? So option A is the answer. This is simple. Consider a system of two particles having masses m1 and m2. If the particle of mass m1 is pushed towards the center of mass of, of particles through a distance d, by what distance would be the particle of mass m2 move so as to keep the center of mass of particles at the original position? So this is a simple question. See, question is, we have system of two particles. Okay, we have system of two particles. First particle is moved by distance d. By what particle should you move second? By what distance should you move the second particle? Okay, so we have these two particles. First one is m, second is m2, and they will have some center of mass, right? So first one is moved by distance d. By what distance should you move the other one such that their center of mass does not change? This is the question. Okay. So you can say that, okay, its center of mass is m1 x1 plus m2 x2 divided by m1 plus m2, right? And it is equal to, so first one is moved by distance d, right? So we can say it is now the position of first one will be what? So it will be x1 plus d, right? It will be x1 plus d. So it is m1 x1 plus d plus, now suppose we move second one by distance, whatever distance, m2 x2 plus, let's call it uh, this distance as x. We have to figure out this, divided by m1 plus m2. Now if you multiply this, so m1 x1 m2 x2 divided by m1 plus m2, it will get cancelled out on both sides, right? It will get cancelled out. So what remains is m1 times d plus m2 times x, okay, divided by m1 plus m2 will be equal to 0. And if you move that m1 plus m2 on left hand side, okay, it will be anything multiplied by 0 is 0, so that will be 0. Again, voice is breaking. Oh, so then we'll have to stop then. Anyways, we'll see the problems tomorrow. And remaining problems we'll see tomorrow. It's the internet issue, my internet issue. Shall we complete this problem? This is uh, okay. This is almost complete, right? Let's complete this one. So now you can move this m2x on the other side. What do you get? So m1 times d will equal to minus of m2 times x. That means if you move, okay, m1 like this, then m2 you will have to move in the opposite direction, right? In the opposite direction. Okay. So and x will be equal to what? So x will be equal to m1 upon m2 times d. Okay, without the sign. Okay. So what's the answer? The answer is m1 by m2 times d. This is the answer. Option B is the answer. Oh, shall I repeat this once again? Okay. See, what I was saying is, see, two particles are there. Okay. And the center of mass of two particles is this. This is the center of mass of two particles, right? So then, first particle is moved by distance d. First particle is moved by distance d. Now, by what distance you should move the second particle such that the center of mass remains same? This was the question. So, you move second particle by distance x. Let's suppose we are moving it by distance x. So, what happens? Now, the new coordinates of first and second particles will be what? For first particle, it will be x1 plus d. For second particle, it will be x2 plus x. And that x we have to find out. Okay. So, then multiply this because center of mass is same. So, I have equated this thing. Okay. So, m1 x1 plus m2 x2 divided by m1 plus m2. This was original center of mass. Now the center of mass becomes what? m1, the coordinate becomes x1 plus d. Okay, for first particle. For second particle, it is x2 plus d, x2 plus x. Okay, and x is we have to find. Okay, so then this m1 plus m2 gets cancelled out. If you multiply this out, what will happen? So m1 x1 and m2 x2, it will also get cancelled out. Okay, right? So that's why you can write m1 times x1, sorry, m1 times d plus m2 times x is equal to 0. And then you can find out x, right? Next question. Three identical metal balls, each of radius r, are placed touching each other on a horizontal surface such that an equilateral triangle is formed when centers of three balls are joined. The center of mass of the system is located at, okay, line joining centers of any two balls. All right, so let me draw it. So we have three balls like this. Okay, so they are touching each other. Three metal balls, they are identical, touching each other. Each of radius r are placed touching each other on a horizontal surface such that equilateral triangle is formed when centers of three balls are joined. So if you join their centers, what will you get is an equilateral triangle. Okay. Question is, where will be the center of mass? Yes, option A, line joining centers of any two balls. Will it be along this line? It will not be. Center of mass will be here. Okay, you can think of symmetry, right? Center of one of the balls can't be there. Okay, center of one of the balls. So it can't be here, right? Center of mass. Horizontal surface. It cannot be on the horizontal surface because mass is above the horizontal surface, right? So point of intersection of three medians. So this is the answer. Point of intersection of three medians. Okay. So if you draw medians like this, 1, 2, 3. So they will intersect at this point. Okay. They will intersect at this point. right? So you can see the mass of the system is equally distributed in all directions about this point. Okay, so this will be the center of mass. Okay, clear? All right. So Ravindran already said it's clear. Good. Then this next question. The center of mass of system of particles does not depend on position of particles, relative distances between the particles, masses of particles, and forces acting on particles. So what's the formula? It is m1 r1 bar plus m2 r2 bar plus so on and so forth. Okay, up to plus upon m1 plus m2 plus so on and so forth up to mn. This is the position vector of center of mass. So it depends on masses. It depends on the positions of these masses. Okay, and because it depends on positions, it means that it depends on the relative distance also. Okay, it depends on this, depends on this, depends on this. It does not depend on this thing. Okay, we can find it out from the formula, right? Okay, good. So next question. Two persons of masses 55 kg and 65 kg respectively are at opposite ends of a boat. So you have a boat. These are two people, okay, on opposite ends of boat. The length of the boat is 3 meters. So length of the boat is 3 meters. Good. Okay, and its weight is 100 kg. Weight of this boat is 100 kg. Okay, the 55 kg man walks up to the 65 kg man. So suppose this is 55 kg man. He walks up to 65 kg man and sits with him. If the boat is in still water, the center of mass of the system shifts back. Option C, right? It's option C because there is no external force. Okay, whatever these masses do internally, right? There won't be any acceleration of center of mass. Okay, it won't change the velocity of center of mass. So if initially the velocity was 0, then again the velocity will remain 0. If it was at rest, the center of mass, then the center of mass will remain at rest. Right? So option C is the answer. Very good, Ravindran. Two particles which are initially at rest move towards each other under the action of their internal attraction. Okay? If their speeds are v and 2v at any instant, then the speed of center of mass of the system will be. Again, the answer must be 0, right? They are moving by the action of internal force. So it can be, let's suppose these are two particles initially at rest. Okay, this is at point A, this one is at point B, and there is gravitational attraction between them. Right, there is gravitational attraction between them. So it is the mutual attraction. Okay, it's the internal force for this system, and therefore, since there is no external force acting on the system, if we think about both the particles, both the bodies, there is no external force, and that's why the center of mass, because initially those particles or those bodies were at rest, so the center of mass was at rest. So because there is no external force, the center of mass will remain at rest. So option B is the answer. The next one, three bodies having masses 5 kg, 4 kg, 2 kg is moving at a speed of 5 meters per second, 4 meters per second, and 2 meters per second respectively along x-axis. The magnitude of velocity of center of mass is. So again, this is simple. So we saw that velocity of center of mass times the total mass. Okay, m times velocity of center of mass is m1 v1 plus m2 v2 plus m3 v3, and you can move that m on this side, so it is m1 plus m2 plus m3 is the m. Okay, so we just have to put the values. So 5 kg times 5 meters per second plus 4 kg times 4 meters per second plus 2 kg times 2 meters per second, and in denominator we have 5 plus 4 plus 2. Okay, so it is 25 plus 16 plus 4. So this is 20. 20 plus 25 is 45. 45 divided by 11. Okay, 45 divided by 11. So it is 1 point something. I'm sorry. It is 4 meters per second. Yeah, sorry. All right. So a block of mass m slides with velocity v along a frictionless level surface towards a block of mass 4m initially at rest. The velocity of center of mass is. So this one is simple, right? So velocity of center of mass is equal to block of mass m moves with velocity v along a frictionless surface towards a block of mass 4m whose velocity is 0. Okay, so m1 v1 plus m2 v2 divided by m1 plus m2, which is m plus 4m. So in numerator we have m times v, denominator 5m. So mm gets cancelled, v divided by 5 is the answer, right? Okay, v divided by 5 is the answer. Simple. Okay, next question. Two bodies of different masses of 2 kg and 4 kg moving with velocities 2 meters per second and 10 meters per second towards each other due to mutual gravitational attraction. What is the velocity of their center of mass? Again, they are moving due to the mutual gravitational attraction. This thing is important. Okay, they are moving due to the mutual gravitational attraction. It's not the external force. So initially they would be at rest. Okay, so no external force is acting, and this velocity is gained by mutual gravitational attraction only. And that means since external force is 0, earlier the center of mass was 0. Okay, sorry, center of mass was at rest. That means its velocity was 0. So it will remain 0. Okay, and that's why the answer is 0. Alright, so let's see this question. A man of 50 kg mass is standing in a gravity-free space at a height of 10 meters above the floor. Okay, there is gravity-free space. So there is some floor, hypothetical floor, this one, and there is no gravity on this floor. And the man is standing in space above the floor, 10 meters above the floor. Okay, so this is that man. He throws a stone of 0.5 kg mass downwards with speed of 2 meters per second. When the stone reaches the floor, the distance of the man above the floor will be. This is the question. So see, so the man is holding a stone. He throws that stone downwards. Okay. So what will happen? So he can only throw the stone downwards by applying some force, right? So equal and opposite force will be applied by the stone on the man also. Okay. Initially both of them were at rest. So what can you say? How much would be the velocity of man if stone moves downwards with velocity of 2 meters per second? 2 meters per second. How much would be velocity of man? So we can say initial velocity was 0, m1 u1 plus m2 u2 is equal to 0. So m1 v1, or let's call man and stone. Okay, so mass of stone times velocity of stone plus mass of man let's call it m only, times his velocity is equal to 0, because initially the man was holding the stone and he is in gravity free space, so he's floating at that point. Okay, so velocity was 0, so final velocity, sorry, total momentum was 0. Okay, and therefore we can find out velocity of man. So v will be equal to what? It will be in opposite direction, right? So let's call this negative. Okay, minus 2 meters per second, and then let's substitute the values. So this is 0, this is mass of stone is 0.5, velocity of stone, because it's moving downwards, I'm calling it minus 2 meters per second, right? Plus mass of man is 50, velocity of man is what we have to find out. So move this on left hand side, so it will be 0.5 into 2, that is 1. Okay, so velocity of man is equal to what? 1 by 50 meters per second. So now the stone reaches the ground. So stone is 10 meters above. In how much time will it reach the ground? In 5 seconds, right? Because its speed is 2 meters per second and this distance is 10 meters. So in 5 seconds it will reach the ground. Now the man was here earlier. Okay, so with this much velocity, how much distance will he cover? How much distance will he move upwards? So it will be distance covered by man. Okay, so distance covered by man, suppose s, it's equal to velocity of man multiplied by time. So that is 1 by 50 multiplied by time is 5 seconds. Okay, so 5 divided by 50 is 0.1. So he was already at 10 meters. Now he moves zero point 0.1 meters upwards. So that means at what height will the man be? 10.1 meters, right? He will be at the height of 10.1 meters. So what is the value of linear velocity if r bar is this, omega bar is this? These are all neat questions. Okay, so how do we find it? V bar is equal to omega bar cross r bar. So it is equal to what? We know how to find out vector product. So it is determinant of I, j, k. So omega x, omega y, omega z in the second row, and rx, ry, rz in the third row, right? So it is 5 minus 6, 6, 5 minus 6, 6, and 3 minus 4, 1 in third row. So let's solve this. This is simple. This I cap multiplied by. So minus 6 times 1 minus 4 times 6. So that will become plus. So minus 6 times 1 is minus 6, plus you have 24. So that is 18. Right? Minus j cap multiplied by. So this thing multiplied by this thing. So 5 times 1 is 5, minus 6 times 3 is 18. So 5 minus 18 is 13. Okay, minus 13. Plus k cap multiplied by this product. So 5 times minus 4, minus 20, minus, and now this will become plus because we have minus 6. So minus 6 times 3, 18, right? So minus 20 plus 18, how much? 2. Okay, so multiply by 2. So which is the answer? 18 I cap plus 13 j cap plus 2 k cap. It is plus, no? No, it's minus, right? This is 5 times minus 4, minus 20, okay, plus 18 is minus 2. So option B is the answer. Okay, this is straightforward. Everybody? Good. Then, so next question is find the torque about the origin when force of 3 3 j cap Newton acts on a particle whose position vector is 2 k cap meters. So what is torque? Torque is, it is 6 I cap or minus 6 I cap. Or is R bar cross F bar, right? So see, R bar is 2 k cap. Okay, it is 2 k cap cross minus. Okay, good. 3 j cap. Right? Remember the rule? Good. Okay. 2 times 3 is 6. Okay. And we have this rule. So when we take cross product of I cap, j cap, k cap. Okay. So we draw a circle. Then we mark 3 points like this. If we go in cyclic order, that means from I to j, j to k, and k to I. So I cross j is equal to k. J cross k is equal to I. And k cross I is equal to j. Okay, but if we go in opposite direction, that means if I take j cross I, then it will be equal to what? Minus k. Okay, if I take k cross j, it is minus I. And that's what we have here. K cross j, it is minus I. Right, so this is minus 1 into I cap multiplied by 6. So minus 6 I cap. Okay, so this is the answer, option C. Simple. So this is another question. The moment of force, this is the force, okay, which is acting at this point, about a point, 2 minus 2 minus 2. So now we don't have to find it about the origin. We have to find it about this point. Okay, so let's suppose this is some point. Okay, so let me explain what is the case. This is one point. Okay, let's call it R1 bar, and you are exerting a force at some other point. You are exerting a force at this point. Let's call it R2 bar. This is R2 bar. Okay, so force is acting at this point. Okay, now you are not asked what is the torque of this force with respect to origin. If it was the case, then it is just R2 bar cross F bar. They are asking what is the torque about this point. Okay, so we have to find this vector first. Okay, we have to find this vector first. Anyways, we have to find out this vector, which is R12 bar. So can you say R2 bar is equal to R1 bar plus R12 bar, right? So what will be? See, R2 bar is equal to R1 bar plus R12 bar. This is by triangle law. R12 bar is equal to R2 bar minus R1 bar. Okay, so you are given with the point. So this is R2 bar. Okay, I mean this is the position of R2, this is position of R1. So we can substitute that. So we get R12 bar is equal to what? This 2 minus 2 minus this 2 into I cap plus 0 minus minus 2. 0 minus minus 2 into j cap. Okay, plus it is minus 3 minus minus 2, or minus 3 plus 2 times k cap. So that is 0 I cap, 2 j cap, and minus 1 k cap. So now what is torque? It is R bar cross F bar. Okay, it will be R12 bar cross F bar. So let's find it out. So torque is equal to I cap, j cap, k cap. Then R is 0 I cap, so 0, 2 j cap minus 1 k cap. And the force is 4, 5 minus 6. Okay, this is the force. So what can I do? I can make this small. No, there is no option. Okay, so let me add a page. So what do we have? I cap multiplied by this thing into this thing, 2 into minus 6 minus 5 into minus 1. So this is equal to I cap multiplied by 2 into minus 6 is minus 12 minus 5 times minus 1 is minus 5. So minus minus plus. So minus 12, okay, to 5. Then j cap multiplied by we have 0 into minus 6. So that's 0 minus 4 times minus 1. So it is minus j multiplied by 4 times minus 1 is minus 4. And then k cap multiplied by you have 0 times 5 minus 4 times 2 is minus 8. Okay, so minus 8 k cap. So let's check. It is what? Minus 7 I cap. Okay, plus 4 j cap minus 8 k cap. This is the answer. Okay, so minus plus minus. Oh, there is no such option. Did I do some mistake? How come? Yeah, it is minus minus. Okay, sorry. It is minus minus. Okay, that will do plus. Right. So this will be minus. Okay. So then option is the answer. Okay, good, Sanjay. All right. So this is straightforward question. Yes. Then there is another question. Force F bar is the thing is acting at a point, this point. The value of alpha for which angular momentum about origin is conserved is. So when is the angular momentum conserved? So what is rate of change of angular momentum? It's equal to torque. So if torque is equal to 0, if torque is equal to 0, angular momentum will be constant, right? L bar will be constant. That means will remain conserved. Okay, so just like when force is 0, momentum remains conserved. Just like that, if torque is 0, angular momentum remains conserved. So angular momentum will be conserved when torque is 0. That means torque bar with R bar cross F bar is 0. So it's IJK. Then we have R bar is 2 minus 6 minus 12. So 2 minus 6 minus 12. Alpha 3, 6. Let's solve this. So what we get? We get that I cap multiplied by 6 times minus 6 is minus 36. Minus 36 plus this 12 times, okay, 3. This is also, but this will be positive. Okay, so I cap multiplied by minus 36 minus minus plus 36. So this will be 0 plus have j cap times what is 6 times 2. Okay, plus minus j. So minus j cap times 6 times 2, which is 12, minus, okay, minus 12 times alpha. So that is plus 12 alpha. Okay, and then you have one more, that is plus k cap times 3 times 2. Okay, plus 6 minus minus, okay, minus 6 times alpha, that is alpha. And for conservation of angular momentum, this thing should be equal to 0. So that means all the components of this vector torque should be equal to 0, right? So you can pick this component or this component involving alpha, right? So 12 plus 12 alpha is equal to 0, or you can say 6 plus 6 alpha is 0. That means alpha is what? It is minus 1. Okay, so 6 plus 6 alpha is equal to 0. It means 6 alpha is minus 6 So alpha equals to what? -1. This is the answer, option C. So let's see next question. When a mass is rotating in a plane about a fixed point, its angular momentum is directed along a line perpendicular to plane of rotation. The line making an angle 45 degrees to the plane of rotation radius the tangent to the orbit. Which is the answer? Right, it is option A. Okay, this is very straightforward. Let's see next question. Again, the next question is similar. Okay, find the torque of a force F bar equals to this thing acting at a point R bar equals to this thing. They are just asking you to do a vector product. Okay, so let's find out torque. It is IJK when 731, okay, R bar and -315. This is M. This is equal to I multiplied by 3 times 5 minus 1 times 1. That's 1. So 15 minus 1 minus J multiplied by, you have 7 times 5, 35 minus 3 times 1. So it's minus 3. Okay. So minus minus plus 3. Plus you have K multiplied by 7 times 1, 7 minus 9, that is plus 9. What's the answer? 14 I cap. Then 35 plus 3 minus 3 J cap plus 16 K cap plus 16 K cap. So option C is the answer. Okay. The next one, again the same question. Okay, so let's do one more vector product. What is the torque of this force acting at a point, about the origin? Torque R is equal to I cap J cap K cap. Then R bar is 3, 2, 3, 3, 2, 3, and force is 2 minus 3. Right. Then this K cap multiplied by 2 times 4. It's 8 minus 9. Okay, minus 3 times 3. Minus 9. So minus minus plus. Minus J cap multiplied this times this. So 12. 12 minus 6. Okay, so 12 minus 6 plus K cap multiplied by, you have 3 times minus 3, which is minus 9 minus 2 times 2, so minus 4. So 20 I cap. Okay. Then minus 6 K cap and minus 13 K cap. This is the answer. Which one? Option D. Right. Option D is the answer. Okay. Then next question. So particle of mass m equals to 5 is moving with a uniform speed v equals to 3 root 2 in XOY plane along the line y equals to x plus 4. The magnitude of angular momentum of particle about the origin is, this is the question. This is slightly different, right? So you have a particle which is moving along this line. What's the line? Y equals to x plus 4. Okay, this is 9. Y is equal to x plus 4. So at x equal to 0, what will be y? Y is equal to 4. So at x equal to 0, y is 4. Right? So 1, 2, 3, 4 you can say. Okay? This 2, 4. So this will be 1 point. Then you can take some other value of x and find out some other value of y. When you have 2 points, you can plot the line. So the line will look like this. The line will look like this. So how much will be this angle? This angle would be equal to 45 degrees. And why so? The reason is, so see, you can say y is equal to mx plus c is the equation of line, if you remember. Okay, m is the slope of the line. Okay, and how can you find slope of line? By using tan of theta, right? So m is equal to 1 here, tan of theta will be equal to 1. That means theta is 45 degrees. Is it clear? Okay, everybody. All right. So the particle is moving along this line, and you are asked what will be its magnitude angular momentum. So think, when particle is at this point, what will be its position vector? Its position vector will be this one. Okay, so it is just force j cap, you can say, right? What is position of this point? 0, 4. Okay, x coordinate is 0, y coordinate is 4. So position vector is 4 j cap. And then this line, it is moving along this line. So its velocity or its momentum will be directed along this line. What's the angle between these two? So this is r bar, this is p bar. What is the angle? R bar is directed like this. Angle is 45 degrees, right? So what will be? What will be what? Angular momentum L is equal to R. It is equal to, it is R bar speed. And if you want magnitude, is rp sine of theta. Okay, that is r into p into sine of 45. So r multiplied by p is mv multiplied by sine of 45 degrees. Put the values. How much is r? Magnitude of r is 4. This is 5 kg. Speed is 3 root 2. And sine of 45 is 1 upon root 2. This thing get cancelled. Root 2 and 1 upon root 2. There is 5 times 3. 15 times 4. 60. Okay. 60 the answer. Questioning. Particle of mass m moves in xy plane with a velocity v on straight line AB. The angular momentum of particle with respect to origin O is LA when it is at A and LB when it is at B. Then LA equals to LB. Relation between A and LB depends upon the slope line LB. Then LA is greater than LB. LA is greater than LB. Which is the answer? There is a particle which is moving with velocity v. Okay, along some straight line AB. Is there a force acting on this particle? Yes, no. Is it given that there is some force acting on particle? Not given, right? There is no force acting on this particle. It is just moving with some velocity. So how much would be the torque acting on particle if there is no force? Torque will be 0, right? Okay. So if torque is 0, what happens to the angular momentum? It remains constant, right? So angular momentum at point A will be just equal to angular momentum at point B. Okay. So angular momentum does not change. It remains constant if there is no torque acting on the particle or body. Got it? Okay, good. Next question. Small mass attached to string rotates on frictionless table. This mass rotates on frictionless table as shown. If tension in the string is increased by pulling the string, causing radius of circular motion to decrease by a factor of 2. Okay, so radius is decreased by a factor of 2. Kinetic energy of the mass will. So what will happen to the kinetic energy? This is the question. Okay, so see what will happen here in this. Okay, in this question. So you are pulling the string, right? You are pulling the string. So this force will be in direction of radius. Yes or no? When you pull the string, the force will be in direction of radius. Okay. So will there be a torque? No torque, right? And direction is same, direction of radius. Okay, or you can say position vector of the particle and the external force that we are using to pull the string. The direction is same. So that means there is no torque. Okay, R bar cross F bar will be equal to 0. So if there is no torque, what will remain constant? Angular momentum will remain constant. Okay, so what is the angular momentum? That is equal to R into P, you can say. Okay, so for a particle perform circular motion, see R and T bar, R and velocity, they are perpendicular to each other. So how much is the angular momentum? So it's R into P multiplied by sine of 90. Okay, sine it is 1, right? Because see, velocity and position vector, they are perpendicular to each other. Okay, so this is just R into P and P equal to mv. You can see this is mv into R is the angular momentum and it will remain constant. Okay, so you can say L1 equals to L2. So original angular momentum was L1. Then when he pulls the string, final angular momentum is L2. It is mv R mv1 r1, let's say, not m1, mvr. Okay, but you are changing the radius, so speed will change. Mass of that particle, mass of that uh, mass will remain constant. Okay, so L2 is m, mass will remain constant, P2 R. Okay, so m and m gets cancelled. And what is R2? So radius is decreasing by factor of 2. That means it will be R1 divided by 2. Okay, it will be R1 upon 2, right? This thing get cancelled. So therefore V2 will be equal to times V1. So if V2 is 2 times V1, how much will be kinetic energy? The velocity increases by factor of 2. The kinetic energy increases by factor of 4 because it is directly proportional to velocity square. Okay, so K will be equal to 4 times K1. Which is the answer? It increases by the factor of 4. This is the answer, right? Let's see this problem. A circular disc is to be made by using iron and aluminium so that it acquires maximum moment of inertia about geometrical axis. Geometrical axis meaning which axis? The natural axis. Okay, so for a disc, it is an axis which is perpendicular to the plane as we have seen and passing through its center of mass. Okay, it is possible with option A, aluminium at interior and iron surrounding it, iron at the interior and aluminium surrounding it, using iron and aluminium layers in alternate order, and sheet of iron is used at both external surface and aluminium sheet at internal layers. We know that aluminium is very light compared to the iron. Okay, so now the formula of moment of inertia. formula of moment of inertia is what? For a disk, you can say it will be integral of dm into r square. Okay, this is the formula for moment of inertia. So, as far this masses from the axis of rotation, moment of inertia would be more. Okay, so if you keep heavier mass away from axis of rotation, because it's directly proportional to r raised to 2, right? So if you keep heavier mass away from axis of rotation, the moment of inertia will be more, and that means you have to keep iron away from axis of rotation and aluminium closer to the axis of rotation. Okay, so which is the answer out of this? It would be this one, aluminium at interior and iron surrounding it. You got this? Yes, no? Let us see next one. Flywheel rotating about fixed axis has a kinetic energy of 360 joule when its angular speed is 30 radians per second. The moment of inertia of flywheel about the axis of rotation is, again, very straightforward, very simple question. The kinetic energy is equal to what? Half of I multiplied by omega square. Okay, let's call it Ke or just K. So it is half of I into omega square. And you want to find out I. So move that 2 and omega square on the other side. So I will be equal to kinetic energy, 2 times kinetic energy divided by omega square. Right, this will go in denominator and this will go to the numerator. So now we just have to put the values. So it is 2 times 360 divided by 30 square. Okay, so 30 square is 900. Okay, so it is I is equal to 2 multiplied by 360 divided by, you can say it's 9 into 10 raised to 2. So 9 fours are 36. So this will be 40. Okay, 42 are 80 and 10 raised to 2. Take it to the numerator. It will be 10 raised to minus 2. So how much? 80 multiplied by 10 raised to minus 2 or 0.8 you can say. Okay, 0.8 kg meter square. This is the answer. Option C. Okay. Right. Let's see next one. So this question, in a rectangle ABCD, BC is equal to 2 times AB. Okay, so this length BC is equal to 2 times AB. The moment of inertia is minimum along axis through. So tell me, which will be the answer? It's a very, very simple question. If you want moment of inertia, let's keep maximum mass closer to the axis of rotation. If you want moment of inertia to be more, keep maximum mass away from axis of rotation. So see, if you take this axis, okay, for an example, this axis, if you take, so there is more mass away from the axis of rotation, right? This length is more, so that means there will be more mass away from axis of rotation. But if you take, okay, uh, what are the options? HF is there, which is HF, this one. Okay, so since for this one, this length is more, okay, compared to you take this thing, okay, if you take BC, so this length is, it would be smaller. Take BD, where is BD? Okay, this is diagonal, so this length would be more. So for this one, the moment of inertia would be more. Then you have EG. So which is EG? This is EG. So now if you take this axis, okay, so mass is distributed at minimum length from this axis, you can say. Yes or no? So moment of inertia will be least for this axis, minimum for this axis. Okay, so this is straightforward. Answer of this question should be EG. The ABC is a triangular plate of uniform thickness. So this is triangular plate of uniform thickness. The sides are in the ratio as shown in the figure. It's the same ratio, right? 3, 4, 5. Okay, it's the same ratio as that of last question. IAB, IBC and ICA are the moments of inertia of plate about AB, BC and CA respectively. Which one of the following relations is correct? Okay, IAB plus IBC is equal to ICA. Okay, then next is ICA is maximum. Is ICA maximum? No. IAB, which is IAB, this is IAB, is greater than IBC. No. Okay, so IBC is greater than IAB. So this one is correct, right? It is straightforward. IBC is maximum. So IBC is greater than IAB because mass is at maximum distance from this axis BC. Okay, so this one is correct. Option D is the answer. Okay, see this. Three particles, each of mass m gram. These three particles are situated at the vertices of equilateral triangle. This is an equilateral triangle ABC of side L centimeter as shown in the figure. The moment of inertia of system about line AX. So AX, we want to find out moment of inertia of these three masses about this line AX perpendicular to AB. So this is perpendicular to AB and in plane of ABC. It is in plane of ABC. In gram centimeter square units will be. So very simple and straightforward, right? So how much will be moment of inertia? I equals to, you can say, for this mass, it is on the axis itself. Okay, so m multiplied by 0 square. For this mass, it is m multiplied by, okay, m multiplied by L square. Length is L. Okay, so m multiplied by L square plus for this mass. So how much would be this distance? If this is an equilateral triangle, so if you draw a perpendicular from here, okay, if you draw perpendicular on this line from here, it will meet at L by 2, right? So its distance is L by 2 from axis of rotation. Okay, so its distance is L by 2. So it is m multiplied by L by 2 square. Okay, so this thing is 0. ml square plus this is ml square by 4. Okay, ml square plus ml square divided by 4. And you can make denominators equal. So you can multiply and divide by 4. So this will be 4 ml square by 4. So 4 plus 1 ml square by 4. So that is 5 ml square by 4. This is the answer. Option C is the answer. Okay, very simple question. Is it clear? Or there is a doubt? A light rod of length L has two masses m1 and m2 attached to its two ends. The moment of inertia of the system about an axis perpendicular to the rod and passing through the center of mass is. Okay, so there is a light rod, that means we have to neglect its mass. Okay, so this is the light rod and there are two masses m1 and m2. Okay, at the two ends of that light rod, and we have to find out moment of inertia of this system about an axis which is perpendicular to the rod and passing through what? The center of mass. So let's suppose, okay, m1 is greater, the center of mass would be towards m1, right? So let's suppose this is the axis which passes through center of mass. So this much length is suppose L1, this much length is suppose L2. So L2 will be equal to what? It will be L, the total length, minus L1, right? Okay. So we can find out L1 and L2. So how much will be L1? So it is distance of center of mass. So this point is center of mass. Okay. So it's distance of center of mass from M1. Okay. So how do you find? So we can start counting distances from M1. So we can say, how will you find center of mass? From M1. Okay. So that length is, that distance is, sorry. So distance of center of mass from M1 is L1. So that is equal to M1 into 0, right? Plus M2 multiplied by, so from M1, M2 is at distance of L. So M2 into L divided by M1 plus M2. Okay, it is M2 times L upon M1 plus M2. That's L1. Similarly, you can measure the distance of center of mass from M2 also. So it will be, okay, just replace M1 and M2. So what do you get? Similarly, distance of center of mass from M2, which is L2, it will be M1 times L divided by M1 plus M2. Or you can find this distance like this also. So L2 will be equal to this total distance minus L1. Okay, so L minus L1, but that would be wastage of time. Okay, as you would put L1 equals to this thing M2 into L upon M1 plus M2. Then you have to make the denominator same, and then you have to do subtraction. Okay, so we'll use our common sense. We'll just exchange M1 and M2. So we'll get L2, distance of center of mass from M2 will be equal to what? It's L2. So it is M1 divided by M1 plus M2 multiplied by total length. Okay, just like distance from M1 is M2 multiplied by, M2 divided by M1 plus M2 multiplied by length L. Is it clear? Everybody? Okay. So now that we have got distances, how much is the moment of inertia? So let me add a page here. Okay. So how much would be moment of inertia? So moment of inertia I is equal to m1 L1 square plus m2 L2 square. Let's put the values of L1 and L2. So we get m1, L1 is m2 into L, m2 times L upon m1 plus m2, and you have square of this whole thing, plus you have m2 multiplied by m1 into L divided by m1 plus m2 whole square. Okay, then you can square, so it will be m1 m2 square L square. So this is m1 m2 square L square, and in denominator of both of these you have m1 plus m2 square. So plus you have m2 multiplied by m1 square L square. Right. So now what you can do is, you can take something common. You can take L square common from both of these terms, and also you can take m1 m2 common. Right. So what will be left from first term? M2 only, and from second term M1 only. So you get M2 plus M1. Okay, so this is what? M1 M2 multiplied by M2 plus M1 multiplied by L square divided by M1 plus M2 whole square. So you can see this thing and this square gets cancelled. I mean, there will be m1 plus m2 left in the denominator. So you get moment of inertia I equals to m1 m2 upon m1 plus m2 multiplied by L square. So this is the formula that you get. Okay. So m1 m2 upon m1 plus m2 L square. Option A. Okay. And now, see, we will memorize this formula also. This is the moment of inertia of two masses. Okay, two masses about the perpendicular axis which passes through the center of mass. Okay, moment of inertia of two masses about an axis which is perpendicular to the line joining two masses and which passes through the center of mass. So it is m1 m2 divided by m1 plus m2 into L square. Okay, and this thing is called as the reduced mass. So got it? Yes, no? This thing meaning m1 m2 upon m1 plus m2 is known as reduced mass. So you get this formula I is equal to. So if you have two masses, okay, rotating about each other, okay. So we have seen system like this. So for an example, a double star system. We talked about double star system. So both of the masses actually revolve around what? Common center of mass. Okay. So for that system, you can say how much would be its kinetic energy. Kinetic energy will be equal to this moment of inertia. Okay, moment of inertia is reduced mass. Okay, mr, r for reduced, multiplied by L square. And how much is the reduced mass? So reduced mass is m1 m2 divided by m1 plus m2. Okay, so kinetic energy will be half of I into omega square, where I is what? mr, the reduced mass, multiplied by L square. So got this? Yes, no? So let's move on to next question. Two bodies have their moments of inertia I and 2I respectively about their axis of rotation. If their kinetic energies of rotation are equal, their angular velocity will be in the ratio. Okay, very straightforward, right? So kinetic energy is equal. So you can say kinetic energy of first one is equal to kinetic energy of second body, right? So it is half of I1 into omega 1 square equals to half of I2 into omega 2 square. Half will get cancelled, and it's given that I2 is equal to 2 times I1. So I2 is how much? 2 times I1. So you can divide this by I1. So 2 will remain there. So omega 1 square is equal to 2 times omega 2 square. Okay, this is what we have. And you want ratio of omega 1 to omega 2. So take that omega 2 on left hand side and take square root. So omega 1 upon omega 2 will be square root of 2 is to 1, you can say. Okay, so option C is the answer. But of mass m and radius r rotates about an axis passing through its center and perpendicular to its plane with angular velocity omega. Its kinetic energy is. What's the answer? Tell me. Option Option A, right? Option A is the answer. Yeah, because moment of inertia is half of I into omega square, and for a ring, how much is the moment of inertia? Mr square only. So it's equal to half of mr square multiplied by omega square. Okay, the ratio of the radii of gyration of a circular disk to that of circular ring, each of small mass and radius around their respective axis. So when they say respective axis, it's always the natural axis. That means perpendicular axis which passes through the center of mass. So we have solved this, right? So for a disk, how much is radius of gyration? It's r by 2. For a ring, it is r. So what's the answer of this? You want this to ring, right? So it is r upon root 2 divided by r. This is radius of gyration for a disk, and this is radius of gyration for a ring. Okay, so r gets cancelled. 1 upon root 2 or 1 is to root 2 is the answer. Okay, so very simple. So let me read it again. The ratio of radii of gyration of a circular disk about tangential axis in plane of the disk. Okay, so this is a disk, right? And you want its radius of gyration about tangential axis. So this is a tangential axis. This is diametric axis. So first of all, we want to find out its moment of inertia about the tangential axis. So we had found this moment of inertia about diametric axis for a disk, I suffix d for a disk is equal to mr square divided by 4. We have solved this, okay, in today's lecture itself. So about this tangential axis, how much would be its moment of inertia? So it for a disk will be what? Using parallel axis theorem, you can say it is id plus mr square, right? So how much is id? It is mr square upon 4 plus mr square. So that is 5 by 4 mr square, right? So we found moment of inertia of a disk about a tangential axis which is in plane of a disk, okay, which is in plane of a disk, okay, and circular ring of same radius and mass about tangential axis in plane of the ring. So for a circular ring, that was disk, this is ring. So for a ring, we know this, okay, id for a ring, how much is that? So about this axis, its moment of inertia is mr square. About this axis, it will be mr square divided by 2. Okay, and you want about the tangential axis. Okay, I about tangential axis, it for a ring. So it will be mr square by 2 plus mr square, because this distance is r, using parallel axis theorem. So it is 3 by 2 mr square. Then you can equate this to what? mk square, and find out radius of gyration. So here it will be root of 5 by 4 r, and here it will be root of 3 by 2 r. Okay, let me add a page here. So k for disk about the tangential axis, it's equal to square root of 5 by 4 r. So we want ratio of k for disk to k for ring about the tangential axis. So this is square root of 3 by 2 r. So this r and r gets cancelled. So it is 5 by 4, and dividing by this is equal to multiplied by its reciprocal. So it is 2 by 3. So this thing, okay, 4 divided by 2 is 2. So 2 times 3 is 6. So it should be square root of 5 by 6. Okay. So option C is the answer. Alright, next one. Moment of inertia of a uniform circular disk about a diameter is I. Moment of inertia about an axis perpendicular to its plane and passing through a point on its rim will be. So again we have disk, its moment of inertia about which axis is given? about its diameter is given. So about this axis, this is given. So you want its moment of inertia about an axis perpendicular to its plane and passing through point on the rim. So not this axis, it will be axis like this. Okay, you want moment of inertia about this kind of axis, right? A point on the rim and perpendicular to its rim. So this is I. They are calling this as I. And I want I suffix z, or let's call this as I suffix t. Let's call it tangent. Okay, so t, and z axis will be like this. So I'll draw it by different color. So now Iz. How much is Iz for a disk? It is mr square upon 2, right, for a disk. Okay, moment of inertia about the perpendicular axis. How much is this? It is mr square divided by 4, right, using the perpendicular axis theorem. How much would be I suffix t? So using a parallel axis theorem, it will be Iz plus mr square. Okay, so it is mr square upon 2 plus mr square, which is 3 by 2 mr square. Okay, and how much is this I? So I is equal to mr square divided by 4. So we can substitute that. So mr square is equal to, you can say 4i. If you take that 4 on the other side, so we can substitute that here. So it is 3 by 2 multiplied by 4 times I. So that is 4 by 2 is 2. 2 times 3 is 6. So 6i is the answer. Option C. Next problem. The moment of inertia of a disk of mass m and radius r about an axis which is tangential to the circumference of disk and parallel to its diameter is. So again we have disk. We want its moment of inertia about an axis which is tangential to the circumference, okay, which is tangential and parallel to the diameter, okay, parallel to the diameter. So this is diametric axis. We want moment of inertia about a parallel axis which is tangential. This is very simple. Okay, so ID for a disk is mr square divided by 4. So this is tangential axis. IT using the parallel axis theorem will be mr square, okay, which is mh square because h is equal to r, plus mr square upon 4. Okay, so 5 by 4 mr square is the answer. Option A. The moment of inertia of a uniform disk of radius r and mass m about an axis touching the disk at its diameter and normal to the disk is. Okay, so diametric axis. Oh, what is this? The moment of inertia of a uniform circular disk. So we have uniform circular disk of radius r and mass m about an axis touching the disk at its diameter and normal to the disk is. I get this should be the rim. Okay, so you cannot have an axis which is touching the diameter, right? Touching the diameter and it's also normal. Okay, so this should be rim, I guess. Should be this axis. Right? So it will be 3 by 2 mr square. So for this axis, it is mr square upon 2. For this axis, it is how much? Mr square upon 2 plus mr square. Okay, using the parallel axis theorem. So it is 3 by 2 mr square. This is the answer. Let's see next question. A thin rod of length L and mass m is bent at its midpoint into two halves. so that the angle between them is 90 degrees. Okay, so you are bending thin rod. So let's suppose you have this rod like this. You are bending it into two halves. Okay, so you have now rods like this, bending at 90 degrees. Moment of inertia of the bent rod about an axis which passing through the bending point. So you want moment of inertia of this thing about this axis and perpendicular to the plane defined by two halves. So you want moment of inertia about this axis. Okay. Yes. Now let's suppose the mass of one of these rods. So let's find moment of inertia of, let's suppose these are two rods. Okay. So moment of inertia of both of them about this point axis which is perpendicular to the rods and passing through this point. So for both of them it will be equal, right? So this is one of those two rods, you can say. So for this mass is m, length is l. For this one mass is suppose small m, which is m by 2, and length is also small l, which is l by 2. So how much would be its moment of inertia about this axis? Okay. So did we solve this? No, right? For a rod, did we solve? Yes, we solved it. It is ml square by 3. Right. Moment of inertia about this axis which is passing through the end. Okay, it's ml square divided by 3 using the parallel axis theorem. Moment of inertia about this axis is ml square upon 12. About this axis, it is ml square upon 12 plus mh square. H will be L by 2. Right, so it is ml square upon 3. We have solved this. Okay, so we can directly use that. So how much would be moment of inertia of this thing? Let's call it I1. It will be ml square upon 3. Okay, and you have two of those, so it will be 2 times. So total moment of inertia of this thing, let's call it I. So I will be 2 times I1, that is 2 times ml square upon 3. But what is this m? M is equal to what? For both of these, it will be equal to half of this mass. And L length is also half of this length. Right? So you have 2 by 3. Okay, m, which is capital M upon 2, multiplied by L is capital L upon 2 square. So this is, you will have ml square, this 2 and 2 gets cancelled, and 2 square is 4, right? 2 square is 4, so you are getting 4 3s are 12. ml square upon 12, if my calculation is correct. So this will be the answer, option D. All right, so let us see next question. Four identical thin rods, each of mass m and length l, small l, form a square frame. Moment of inertia of this frame about an axis through center of square and perpendicular to its plane is. Okay, so you have four rods like this. So you have a frame like this. You want moment of inertia of this about an axis which passes through this point, central point, and it is perpendicular to all of them. Okay, all of these rods. I mean, it's perpendicular to the plane of the frame. How much would be moment of inertia? So we know moment of inertia of a rod about a perpendicular axis which passes through this point, it is ml square upon 12, right? For this point, it will be ml square upon 12 for this rod. Similarly, for this rod, it will be, for this point, it will be ml square upon 12, right? For all of them, it will be ml square upon 12, ml square divided by 12 about an axis which passes through their midpoint. Okay, now you want moment of inertia of this rod about this point. Okay, and two axes are perpendicular. Axis passing through this point as well as this point. They are parallel to each other. Sorry, they are parallel to each other. So you can use parallel axis theorem. So this distance is h. How much will be this distance? If this length is L, this distance will be L by 2, right? So I can say for one rod in the frame. Okay, so let's call this point O. IO is equal to IC plus MH square, which is ML square. It's capital M. Okay, so ML square upon 12 plus M multiplied by L by 2 square. So it is ML square upon 4. Right, this will be ml square upon 4, or this is ml square upon 12 plus this is ml square divided by 4, or you can say 3 by 12 ml square. So this will be how much? 4 by 12 ml square, or you can say it is ml square upon 3, ml square upon 3. So this is for one of these rods. You have 4 such rods. So for 4 such rods, that is for this frame, how much would be moment of inertia about an axis which is passing through this point, and it's perpendicular to its plane? It is 4 times of this, right? So it is 4 ml square divided by 3. This is the answer, option D. So this is how we can solve questions based upon this thing, parallel and perpendicular axis theorem. All of them are simple. Okay, let's see one more. The moment of inertia of a thin uniform rod of mass m and length L about an axis passing through its midpoint and perpendicular to its length is IO. This is thin rod. So it's given that moment of inertia about this axis, it's IO. Okay, axis which is passing through its midpoint, right, perpendicular to its length, it's IO. Its moment of inertia about an axis passing through one of its ends and perpendicular to its length is. Okay, so we had solved this, right? So you want moment of inertia about this axis. So it will be IO plus this distance is suppose h, which is L by 2. So it is IO plus mh square, right? Let's call it I only. So I will be equal to IO plus mh square. So it is IO plus m L by 2 square, which is ml square by 4. Okay, so option B is the answer. So let's see one more problem. The moment of inertia of a uniform disk is maximum about an axis perpendicular to the disk and passing through. Which point? Is it this point, this point, this point, this point? It will be this point, because IO is equal to IC, that is moment of inertia about this point, about an axis which is passing through this point, plus mh square. Okay, and if h is more, then moment of inertia will be more. So compared to this point and this point, distance of this point is more, right? So therefore, moment of inertia about this point, about an axis which is passing through this point would be more. Very, very straightforward question. A solid sphere is rotating freely about its symmetry axis in free space. The radius of sorry, the radius of the sphere is increased keeping its mass same. Which of the following physical quantities would remain constant for the sphere? A is angular velocity, B is moment of inertia, C is the rotational kinetic energy, and D is angular momentum. So who can tell? Now, what are you doing? You are changing its radius, keeping the mass same. Okay. So now, if you are not exerting any external torque in doing this, something will remain constant. Which is that quantity which remains constant? Angular momentum, right? So it is option D. This is the answer. Okay. Two disks of same moment of inertia rotating about their regular axis. So we have two disks, they have same moment of inertia, okay, and they are rotating about the regular axis. That means an axis which passes through their center of mass, okay, and it is perpendicular to plane of the disk. They have angular velocities omega 1 and omega 2. They are brought into contact face to face, coinciding the axis of rotation. So they are kept on each other. Okay. So this is first disk, you can say. Okay, this is second disk. They were rotating with some angular velocities. Okay, omega 1, omega 2, and the moment of inertia is same. Okay, now they are kept on each other. What will happen? So this is like collision. Okay, but there is no external torque. If you think about system of these two bodies only, there is no external torque that is acting. So you can say the angular momentum will be conserved. Okay, so question is the expression for loss of energy during this process. So what will be loss in kinetic energy? That's what we have to find. So now you can say L1 plus L2. Okay, total angular momentum before the collision equals to total angular momentum after the collision. So I times omega 1 is angular momentum of first disk plus I times omega 2. This is the angular momentum of second disk. It's equal to. Now, when you keep those two disks onto each other, the total moment of inertia will be what? 2I. Okay, so total moment of inertia will be 2I. And we don't know about the angular velocity. We have to find it out. So let's suppose angular velocity is omega. Omega final, you can say. Or let's call it omega only, because for initial angular velocities, it is omega 1 and omega 2. So I gets cancelled, right? You can take I common and cancel it out. Okay, then you take the 2 on the other side. So you get omega equals to omega 1 plus omega 2 divided by 2. Okay, so loss in kinetic energy, let's call it delta K. It is K initial minus K final. So it is half of, okay, I into omega 1 square. This is initial kinetic energy of first body plus half of I into omega 2 square. This is for second body. Okay, this is the total initial kinetic energy minus it is half of moment of inertia of two bodies. Okay, final moment of inertia is I multiplied by omega square, right? So now, can I add a page here? So we want to find out the change in kinetic energy. Okay, the difference in kinetic energy. So now, how much is omega? It is omega 1 plus omega 2 divided by 2. So meanwhile, this 2 and 2 gets cancelled out, right? 2 and 2 gets cancelled out. So this is equal to, you can say it is half of I omega 1 square plus half of I omega 2 square minus I into omega square. Okay, I multiplied by omega square, which is omega 1 plus omega 2 divided by 2 square. Okay, so now let's square this. So we get half of I omega 1 square plus half of I omega, this was 2, omega 2 square minus, this is, if we square this, it will be omega 1 square plus omega 2 square. Okay, so it is 1/4. If you square this 2, it will be 1/4. Right, 1/4 I multiplied by omega 1 square. I will just expand the terms, right? Minus 1/4, sorry, 1/4 I multiplied by omega 2 square, and minus you will have 1/4 multiplied by I multiplied by 2 times of omega 1 into omega 2. Okay, this is what we'll have, right? So then you can subtract this out. So you will get this is half of I omega 1 square minus 1/4 of I omega 1 square. So 1/4 of I omega 1 square will remain, right? Half minus 1/4 is 1/4. So 1/4 of I omega 1, 1/4 of I omega 1 square. Similarly, you will have half of I omega 2 square minus this 1/4 of I omega 2 square will be plus 1/4 of I omega 2 square, and minus you have 1/4 of this thing. Okay, 2 times I omega 1 multiplied by omega 2. So you can take 1/4 common, right? 1/4 common, and I also you can take common. Okay, so it will be omega 1 square plus omega 2 square minus 2 times omega 1 into omega 2, right? You will have that. Okay, yeah, so you will have that. So you will get 1/4 of I am taking common. It is omega 1 square plus omega 2 square minus 2 times I omega 1 multiplied by omega 2. So this thing is omega 1 minus omega 2 square, right? So we have 1/4 of I multiplied by omega 1 minus omega 2 square. This much is the loss in kinetic energy, right? Okay, so it is option A. Option A is the answer. So is it clear, or is there a problem? Two rotating bodies A and B of masses m and 2m with moment of inertia Ia and Ib is greater than Ia, have equal kinetic energy of rotation. If LA and LB be their angular momenta respectively, then. Okay, this is very simple. Tell me which is the answer. See, they have equal kinetic energies. So Ka equals to Kb, right? Okay. So after that, what's given? Ib is greater than Ia. Moment of inertia of second body is greater than first body. Okay. So it is half of Ia multiplied by omega A square. Okay. It's equal to half of Ib multiplied by omega B square. Okay. So now half and half you can cancel out. So then what you can do is you can do the same trick that we had done earlier. So you can multiply and divide by Ia. Okay, so this will be Ia omega A whole square divided by Ia. It's equal to Ib omega B whole square divided by Ib. Okay, right? So what is this thing? This is angular momentum of first body. Okay, this is La. La square upon Ia equals to Lb square upon Ib. That's what you have. Okay, so then you can write La by Lb square. I mean, you will take this on the other side. Okay, So it's equal to IA upon IB, right? If you take this IA on right hand side, okay. So now if you take square root, it will be square root of IA by IB. You answer option C. Okay, what is option C? LB is greater than LA, right? Exactly. Because IB is greater than IA, okay, you have LA upon LB square equals to I upon IB. So this thing will be less than 1. Okay, this thing will be less than 1 because IB is greater than IA, right? So then you can take LA upon LB, it's equal to square root of IA upon IB. This is less than 1 because IB is greater than IA. Okay, therefore the square root will also be less than 1. So LA upon LB is less than 1. Take LB on other side. So you get LA is less than LB or LB is greater than LA. Option C. Two disks are rotating about their axis. Normal to disks and passing through the centers of disk. Disk D1 has 2 kg mass and 0.2 meter radius and initial angular velocity of 50 radians per second square. Disk D2 has 4 kg mass, 0.1 meter radius and initial angular velocity of 200 radians per second. Two disks are brought in contact face to face with their axis of rotation coincident. The final angular velocity of the system is. This is simple. Okay. So angular momentum is conserved when you keep two disks one on the other. Okay. I1 omega 1 plus I2 omega 2 will be equal to what? I1 plus I2 multiplied by omega. Okay. So total initial angular momentum, because the disk were separate. Okay. So angular momentum of first one is I1 omega 1. Angular momentum for second one is I2 omega 2. Now you are keeping the one on other. Okay. You are combining them. So total moment of inertia will be I1 plus I2, right? And angular velocity is suppose omega. Okay, so angular momentum will be I1 plus I2, which is moment of inertia multiplied by omega. Okay, then these are disks. So how much is moment of inertia? I mean, what's the formula for this moment of inertia about an axis passing through the center of mass? It is half of m into r square, right? So it is half of m1 r1 square omega 1 plus half of m2 r2 square omega 2. Okay, it's equal to I1 plus I2. So you can take half common, m1 plus m2, sorry, m1 r1 square plus m2 r2 square. Okay, it is mr square upon 2, right? I have taken that 2 outside, and omega is what we have to find out. Okay, so half gets cancelled out. Okay, then sorry, we can substitute the values here. So how much is m1? M1 is 2. So it is 2, sorry, 2 multiplied by R1 is 0.2, 0.2, or let's do one thing. Let's write omega equals to M1 R1 square omega 1 plus M2 R2 square omega 2 divided by M1 R1 square plus M2 R2 square. Okay, if you take this bracket on the other side, right, then we can substitute for the values. So it is m1. How much is m1? It is 2 multiplied by r1 square is 0.2 square. Omega 1 is 50. Oh, this won't be sufficient, right? So here we'll substitute the values, right? So m1 is how much? It was 2. Okay, m1 is 2. R1 is 0.2 and omega 1 is 50. So it is 2 multiplied by 0.2, sorry, 0.2 square multiplied by 50 plus m2 is how much? M2 is 4 multiplied by zero point 0.1, okay, square multiplied by 200. So 4 multiplied by zero point 0.1 square multiplied by, what was it, 200. And in denominator we have 2 multiplied by zero point 0.2 square, so 2 multiplied by 0.2 square plus 4 multiplied by 0.1 square. Okay, so we have to do all this calculation. So 0.2 square, it is 2 multiplied by 10 raised to minus 1 square, which is 4 times 10 raised to minus 2. Okay, so this is 4 multiplied by 50. Okay, let's do that. So 4 into 10 raised to minus 2 multiplied by 50 plus this thing is just 10 raised to minus 2, right? Because 0.1 means 10 raised to minus 1. So 4 times 200. Okay, it is 800 multiplied by 10 raised to minus 2. And in denominator we have again the same thing. It is 4, 2 times 4 into 10 raised to minus 2 plus 4 multiplied by 10 raised to minus 2. So 10 raised to minus 2, we can take it common and cancel it out throughout, right? And then it is just 50 times 2 is 100. Sorry, 50 times 4 is 200. 200 times 2 is 400 plus 800 divided by, we have 4 times 2, how much? 8. 8 plus 4, 12. So it seems 1200 divided by 12. Okay, right? So omega equals to 100 radians per second should be the answer. All right, let's check whether we have got, yes, option B is the answer, 100 radians per second. So this one was straightforward, just some calculations, right? Okay, let's see next one. Okay, when I'm adding a page, it is getting copied. Okay, next one. A circular platform is mounted on a frictionless vertical axle. So there is a circular platform which is mounted on a frictionless vertical axle. Okay, its radius r is equal to 2 meters and moment of inertia about 200 kg per meter, sorry, kg meter square. It is initially at rest, so that platform is at rest. A 50 kg man stands on edge of the platform and begins to walk along the edge at the speed of 1 meters per second relative to the ground. Time taken by man to complete one revolution is, okay. So what is given? This is nice question. It's from mains. There is this platform, circular platform, okay, and this is an axle. Okay, this is an axle, or you can say it's axis of rotation, right? So then there is a man who walks on this platform. So when he will walk on the platform, what will happen? Can you guess? Yes. Can you guess what will happen? So let's suppose the man walks in anti-clockwise sense. Okay, so it's given that the platform is initially at rest. 50 kg man stands on the edge of the platform and begins to walk along the edge at the speed of 1 meters per second. So he walks like this along the edge. Okay, so the platform will move in opposite direction. The platform will rotate, right? Yes, no? See, initially the man and the platform, they were at rest. Okay, so total angular momentum was 0. Now when man begins to move, okay, when man begins to move along the edge of the platform, what happens? There will be some angular momentum, okay, associated with the man. So when he moves in forward direction, he is pushing that platform in backwards direction, right? And because of, sorry, sorry. So because of this, see, the man is moving like this in forward direction. So platform gets a push in backwards direction. And because of that push, now the platform will rotate. Yes, no, because it is mounted on that axis of rotation. It is mounted on the axle. Can you imagine this? Yes, no? All right, good. So now what can we say about this rotation? So initially both were at rest. Okay. So angular momentum of platform and angular momentum of the man was 0 initially. Afterwards, suppose L suffix m is the angular momentum of man and L suffix p is the angular momentum of platform. So how will you find out angular momentum of man? Now man is performing circular motion. So his angular momentum is what? It is moment of linear momentum, r multiplied by, okay, it is r multiplied by linear momentum, which is m into v, right? Okay, and angular momentum of this platform, which is disk actually, it is I into omega plus I times omega. Okay, so now we can find out how much is this angular momentum. So let's move this on left hand side. So we get I times omega. Okay, I times omega equals to what? Minus r multiplied by m into v. So how much is I? I is half of m into r square. So how much is its mass? So small m is mass of man. Let's call mass of ring. Okay, m is mass of ring. It's 200 kg. Okay, sorry, not ring. I'm sorry. So this m is mass of disk. It is 200 kg. Or the moment of inertia is given. Sorry, moment of inertia is given. Okay, moment of inertia is disk. Moment of inertia of the disk is directly given, right? So now we can find out omega. Okay, so omega will be equal to what? Minus of rmv divided by I. So now we can substitute the values. R is how much? R is 2 meters. M is 50 kg. And he is moving with the angular velocity of how much? Sorry, with the velocity of 1 meters per second squared. So 1 divided by I is 200. It's given. Okay. So what do we get? We get 2 into 50 is 100. 100 divided by 200 is 1 by 2. Okay. So this is minus 1 by 2. Okay. Radians per second squared. So what will this minus 1 by 2 mean? It means that when man moves in this direction, okay, the disk will move in the opposite direction, right? Yes, no? All right. So then the question is time taken by man to complete one revolution. Okay, see, Now it's like two objects are moving towards each other. So let's suppose man starts from this point. Okay, man is moving in this direction, the disk is moving in opposite direction. Okay, so if only the man was moving, we could find out the time very easily, right? What could be the time? If disk was stationary, then it is just 2 pi r divided by, okay, see, v equals to 2 pi r divided by t, right? So t will be equal to what? 2 pi r divided by v. Okay, so if just man was moving, this could be the time period. Now disk is also moving in opposite direction. So what do we have to find it out? Find out the velocity of man with respect to disk, right? The velocity of man with respect to the disk. Okay, so let's do that. So now, how much would be the velocity of any point on the edge of this disk? Okay, we can say velocity of the point at edge of the disk, because this is what matters, right? Only the point on edges, the points on circumference of the disk, they are coming towards man. Okay, so it is r times omega, right? So velocity of disk, we can say it is r times omega. So it is r multiplied by omega of the disk. Okay, which we found out. So r is 2 meters, omega is minus half. Okay, omega is minus half, right? So what do we get? Okay, so this is minus of r is 2, omega is, this is 2 times, okay, omega is minus half, right? R is 2, omega is minus half. So it is minus 1 meters per second, you can say. Okay, so now the time period will be equal to, or here the relative velocity of man, okay, with respect to the disk is equal to what? It is velocity of man minus velocity of disk. Okay, velocity of edge of the disk, you can say, or circumference of the disk, because man is moving on circumference only. So circumferential points of the disk, they are coming towards man. Okay, so it is 1 minus this minus 1, or you can say it is 2. So time period will be equal to what? 2 pi r divided by velocity of man with respect to the disk. Disk meaning the circumference of the disk, circumferential points of the disk. They are moving, okay, towards the man, right? So it is 2 pi multiplied by r. How much is r? It's 2 divided by this 2. Okay, so 2 gets cancelled. 2 pi should be the answer. 2 pi, yeah, option C. 2 pi seconds should be the answer. So is it clear? Circular disk of moment of inertia I suffix t is rotating in a horizontal plane about its symmetry axis with a constant angular speed omega I. Okay. Another disk of moment of inertia IB is dropped coaxially. So this is similar, okay, onto the rotating disk. Initially, the second disk has zero angular speed. Eventually, both the disks rotate with constant angular speed omega f. The energy lost by the initial rotating disk to friction is, okay, due to friction is. So this is similar, right? We have recipe to solve this. So let's solve this. So moment of inertia of first one is it, moment of inertia of second one is ib. Okay, and initially only the first disk is rotating. So you can say, sorry, the initial angular momentum, total initial angular momentum is equal to total final angular momentum, because there is no external torque. So how much is initial angular momentum? L initial equals to L final. Okay, so it is just it multiplied by omega I. Okay, omega I is its speed. Okay, angular speed. So it's equal to, then another disk of mass IB, sorry, moment of inertia IB, it is dropped onto the first. So now moment of inertia is IT plus IB, and the angular velocity becomes, suppose, omega. So their angular velocity is omega. Okay, so from this we can find out omega equals to what? It is IT divided by IT plus IB multiplied by omega I. Okay, and we want to find out energy lost. Okay, so let's add a page. Let's rotate the page. Okay, so initial kinetic energy is, so how much is energy loss? So delta K is initial kinetic energy minus the final kinetic energy. So initial kinetic energy is half of I suffix t multiplied by omega I square, minus final kinetic energy is half of I is now IT plus IB. Okay, and how much is omega? Omega is this thing, IT upon IT plus IB multiplied by omega I. So IT divided by IT plus IB multiplied by omega I, and we have square of this, because this is final angular velocity, right? So half of I multiplied by omega square is kinetic energy. So now uh, final moment of inertia is IT plus IB. Final kinetic energy is, sorry, final angular velocity is this thing. Okay, so then we have to solve this. So this IT plus IB square we have, it gets cancelled with this thing. So we'll have only IT plus IB in denominator. So we are left with half of IT to omega I square minus half of IT, no, it will be IT square omega I square divided by IT plus IB in the denominator. Okay, and then we have to do some simplification. We can take this whole term common. So we can take half of IT multiplied by omega I square common from both the terms. Okay, so we are left with 1 minus. So from here, it is IT upon IT plus IB. Okay, then we can make the denominator same. So here we'll multiply and divide by IT plus IB. Okay, so it will be this term, the first term. Okay, this thing multiplied by IT plus IB minus IT. IT plus IB minus IT, and in denominator we have IT plus IB, right? So IT and IT gets cancelled out. IT and IT gets cancelled out. So it is IB upon IT plus IB. Okay, so IT times IB. So we get IT times IB upon IT plus IB multiplied by omega I square. This is the loss in kinetic energy. Okay, so nothing difficult, right? Nothing difficult. So where is the, oh, this one. Option D is the answer. Okay, so this is, we have recipe and we are following the recipe. That's it. Okay. A thin circular ring of mass m and radius r is rotating about its axis with constant angular velocity omega. So when it is said that about its axis, it means that about the natural axis, which passes through the center of mass and it's perpendicular to the plane, okay, plane of the body. So this is the ring, okay. What is its axis? It is this perpendicular axis, okay, this perpendicular axis, right. It passes through the center of mass, okay. So then two objects, each of mass small m, are attached gently to the opposite ends of diameter of ring. So two masses are connected here, okay. So two masses are connected gently here, okay. So those masses will also begin to move along with the ring. The ring now rotates with angular velocity given by. This is straightforward, very simple question. So initial angular momentum equals to final angular momentum, right? So initial angular momentum was moment of inertia of disk, moment of inertia of sorry. So initial angular momentum equals to final angular momentum. L initial equals to L final. You can say initially there was that ring only. So I of the ring multiplied by omega of the ring, that's omega only, equals to, okay, final angular momentum is I of ring plus moment of inertia of these two masses. So that will be 2 times mass is small m, right, mass is small m, okay, m multiplied by r square, okay, mr square multiplied by omega final, okay, and we have to find out final omega only. So I of ring is what? It is capital M into r square. So capital M into r square multiplied by omega equals to capital M into r square. No, it is the same r, small r square, right, plus this 2 small m into r square multiplied by omega f. So this r square gets cancelled out. Okay, r square, r square, r square, you can take common and cancel it out. Okay, so omega f is equal to, on left hand side you have m and you can take this m plus small 2m, okay, on that side it goes in denominator, okay, multiplied by omega. So option B is the answer. Very simple, straightforward. A round disk of moment of inertia I2 about its axis perpendicular to its plane and passing through its center is placed over another disk of moment of inertia I1 rotating with an angular velocity omega about the same axis. So there is a disk whose moment of inertia is I1, it's rotating about some axis, okay, and another disk of moment of inertia I2 is kept. The final angular velocity of the combination of disks is, oh, this is great, just similar to last question, right? So L initial equals to L final because there is no external torque. Okay, so L initial is what? I1 multiplied by omega. L final is what? I1 plus I2 multiplied by final angular velocity is omega f. And now take I1 plus I2 on left hand side. So you get omega f is equal to I1 upon I1 plus I2 multiplied by omega. Okay, so option A. This was simplest one. Let's see. Oh, this is I1. Sorry. This is C. Right. A thin circular ring of mass m and radius small r is rotating about its axis with constant angular velocity omega. Four objects. So earlier it was two, now there are four objects, are kept gently to the opposite ends of two perpendicular diameters of ring. The angular velocity of the ring will be. So who can just observe and tell me? Just observe and tell me which would be the answer. Right, exactly. It will be option B. Okay. So that's, do you agree or we need to solve this? So option B is the answer for this. Okay. Let's solve next one. A disk is rotating with angular speed omega. If a child sits on it, what is conserved? Again, this is repeated. Tell me. Right. Angular momentum is conserved. Okay. Because there is no external torque of on system of these two bodies. So angular momentum is conserved. The instantaneous angular position of a particle rotating, sorry, the instantaneous angular position of a particle on a rotating wheel is given by this equation. The torque on the wheel becomes zero at, okay. So tell me, what should we do? Tau equals to I multiplied by alpha, right? So we are given with theta. So if we take d theta by dt, what do we get? We get 3 multiplied by 2, okay. This is 2t cube. So 3 multiplied by 2 into t square minus 6 multiplied by derivative of this t square is 2 times t. Okay, so 6 t square minus 12t. So this is omega. Okay, if we take d theta by dt, and alpha is equal to d omega by dt. So that is, if we take derivative of this, it will be 6 multiplied by 2t minus derivative of this will be just 12. So when torque is 0, the I cannot be 0. I means moment of inertia cannot be 0. Alpha has to be 0. So alpha is 0. So 12t equals to minus 12 is 0. Okay. Therefore t is equal to what? 1. 1 second. This is the answer. Right? Next question. A wheel has angular acceleration of 3 radians per second squared and an initial angular speed of 2 radians per second. In a time of 2 seconds, it has rotated through an angle of, tell me, angular acceleration is given, then angular speed is given, initial angular speed, and time is given. So this is second kinematic equation. Theta equals to omega naught multiplied by t plus half of alpha into t square, right? Just like s is equal to ut plus half at square. Okay, so omega naught is given, it's 2 multiplied by time is 2 plus half of alpha is 3 multiplied by t square, it is 2 square. So 4 times what? This will be 4 divided by 2. So 2 times 3 is 6. Okay, so 4 plus 6, 10. 10 radians is the answer. Very simple, right? So let's see next question. A wheel having moment of inertia 2 kg meter square about vertical axis rotates at 60 rpm about this axis. Torque which can stop the wheel's rotation in 1 minute would be. So we know tau is equal to I times alpha. Okay, alpha we can find out. It is omega final minus omega initial. Okay, omega 0 divided by time. Okay, so what is omega initial? So omega 0 is 2 pi multiplied by f0. Okay, so it is 2 pi multiplied by f is 60 rpm. So that is 60 by 60 rps, right? 60 revolutions per minute. That means how many revolutions in a second? One revolution in a second, right? 60 by 60. It is 2 pi radians per second. Okay, so this is equal to omega final is 0. It is stopping. Okay, so omega final is 0 minus we have 2 pi divided by time. How much is time? 1 minute, meaning 60 seconds. Okay, so it is minus 2 pi upon 60, or you can say pi upon 30. So alpha is minus pi upon 30 radians per second square, and tau is I alpha. So tau is I into alpha. So I is 2 multiplied by, you have minus pi by 30, which is, okay, pi by 15. Okay, minus pi by 15, right? Newton meters. This would be the answer. Okay, so option C is the answer, right? So negative sign is because torque is acting so as to stop the wheel. That's why we have negative sign. So let's move on to the next question. A rope is wound around a hollow cylinder of mass 3 kg and radius 40 centimeter. What is the angular acceleration of the cylinder if rope is pulled with a force of 30 newtons? So if you pull the rope with, see, you have what? A hollow cylinder. Okay, it's a hollow cylinder like this, and a rope is wound to this cylinder, a hollow cylinder. Okay, so there would be this rope is wound like this, and you pull this rope. Okay, you pull this rope with some force, not some force, with a force of 30 newton. Okay, so F is given, F is equal to what? 30 newtons. So when you pull this rope, what will happen? There will be a force, tangential force acting on this cylinder. Okay, and due to which there will be torque. Okay, there will be torque. So how much would be torque? So this is R. Okay, so torque will be equal to what? R multiplied by F multiplied by sine theta. So how much is sine theta? Because R and F are at 90 degrees. Force is tangential. So angle is 90 degrees, right? So sine 90 is 1. So R times F will be the torque. Tau is just equal to R multiplied by F. Okay, and you want angular acceleration. So you can write it as, okay, tau is I alpha, which is equal to R times F, and therefore alpha is equal to Rf divided by I. So what is its moment of inertia? Moment of inertia of hollow cylinder is, what is the formula? It's mr square, right? Okay, so R times F, so this R and R gets cancelled out, F upon mr. So alpha is F upon mr. F is 30, m is 3, and R is 40 centimeters. That means 0.4. Okay, or let's write it as 4 into 10 raised to minus 2 in meters. So this is 30 divided by 3 is 10. Okay, you take 10 raised to minus 2 in numerator, it becomes 10 raised to plus 2. So 10 times 10 raised to plus 2. This is 1000 divided by 4. How much? Okay, so then yes, it will be 100 divided by 4. Okay, so 25 radians per second square. This is the answer. Okay, option B is the answer. A solid sphere, disk, and solid cylinder, all of the same mass and radius, are allowed to roll down from rest on the inclined plane. Then, so they are allowed to roll down from rest on the inclined plane. Then solid sphere reaches the bottom first, solid sphere reaches the bottom last, then the disk will reach the bottom first, all reach the bottom at the same time. This is the question. Okay, so now see the time taken by these bodies to reach the bottom. Okay, the time taken by these bodies to reach the bottom, it is given by this formula. Okay, so T is equal to what? T is equal to square root of 2s upon g sine theta multiplied by 1 plus k square by r square. This is the formula. Okay, so which is uh, which is the different thing for these bodies? Oh, I already circled it. So it is k, right? It is k. So if k is small, radius of gyration is small, then they will roll down in less time, faster. Okay, if k is more, then time taken to roll down will be more. Okay, so k is more, the time taken will be more. If k is small, then the time taken will be less. Okay, so what is moment of inertia of these bodies? Solid sphere is 2 by 5 mr square. Okay, that means radius of gyration is what? K is equal to root 2 by 5. Okay, root 2 by 5 r for solid sphere. For disk, okay, this is for sphere. For disk, how much is it? So moment of inertia is mr square. That means radius of gyration is, sorry, moment of inertia is half of mr square. So radius of gyration is r upon root 2. And solid cylinder. So for solid cylinder, it is mr square only. Okay, moment of inertia is, sorry, solid cylinder, it is mr square by 2. So radius of gyration is r upon root 2 for cylinder also. So for the disk and for cylinder, it is same, k is same, and for sphere it is less. Okay, that means the sphere will take lesser time compared to the disk and cylinder, right? Okay, so let's see this next question. A solid homogeneous sphere of mass m and radius is moving on a rough horizontal surface, partly rolling and partly sliding. During this kind of motion of sphere, option A, total kinetic energy is conserved. The angular momentum of sphere about the point of contact with plane is conserved. Only the rotational kinetic energy about the center of mass is conserved. And option D, angular momentum about the center of mass is conserved. Which one will be correct? When it slides on rough surface, what will happen? Its speed will increase, decrease. Decrease, no? What will happen? Kinetic energy, will it be conserved? Speed decreases, kinetic energy will be conserved or not? Not conserved, right? Speed is decreasing, no? Okay, it is rough surface. It's given its rough surface. Okay, and it is partly rolling and partly sliding. If it slides on rough surface, speed will decrease, so kinetic energy is not conserved, right? Then the angular momentum of a sphere about the point of contact with the plane is conserved. Okay, so angular momentum of sphere about the point of contact with the plane is conserved. Okay, this will be true. Why is this true? See, Now, if you consider the point of contact, so suppose this is point of contact. So now frictional force will be there. Okay. So if this body is rolling like this, okay, if it is rolling and moving in this direction, suppose in this direction, then the frictional force will act in this direction if the body slips in this direction, right? So frictional force passes through this point, the point of contact, okay? And there is another force, gravitational force. So now this is center of mass, okay? Gravitational force acts through the center of mass, but the center of mass is above this point, the point of contact, right? The center of mass, sorry, this force, gravitational force also then passes through this point, okay? So the line of action of gravitational force passes through this point, okay? And the frictional force also, it acts like this. So there will be no torque due to the frictional force about this point, and also there will be no torque because of the gravitational force also. Why? Torque is equal to what? It is perpendicular distance multiplied by force. Okay. So how much is perpendicular distance of this point? Sorry, of this force, frictional force for this point? Perpendicular distance is 0 because the frictional force passes through this point. Okay. So if you consider, let's say this point, and the force is like this. If the force is like this, then there would be some perpendicular distance, this much perpendicular distance. But if the force itself passes through the point, then there is no perpendicular distance, right? So torque will be equal to 0. So torque due to frictional force is 0. Torque due to the gravitational force is also 0, right? Because it also passes through this point. So since there is 0 torque, okay, there are only these two forces and 0 torque, and therefore angular momentum, sorry, angular momentum about this point will be conserved. Let's move on to the next question. The speed of a homogeneous solid sphere after rolling down an inclined plane of vertical height h from rest without sliding is, okay, speed of homogeneous solid sphere. It is solid sphere. So this is direct question. We know V is equal to what? Square root of 2gh upon 1 plus k square by r square. Okay. So which is equal to, what is k for solid sphere? So moment of inertia of solid sphere is what? It is 2 by 5 mr square, right? And therefore k will be equal to what? If you equate this to mk square, okay, mk square is equal to 2 by 5 mr square. You can find out k. So k will be equal to square root of 2 by 5 r, or k square equals to 2 by 5 r square, because this m and m will get cancelled for solid sphere. Okay. So now we can substitute that. So what do we get? It is 2gh divided by 1 plus k square by r square. So we can directly find out k square by r square from here. If we take r square on this side, so k square upon r square will be 2 by 5, right? It will be 2 by 5. Okay. So this is equal to square root of 2gh divided by, now this is 5 by 5, 1 is 5 by 5, 5 by 5 plus 2 by 5 is 7 by 5, right? 7 by 5, and you can take that 5 in the numerator, so it is 10 by 7. Okay, so square root of 10 upon 7 gh. So option A is the answer, right? It's very simple. Okay, right. This is a direct question. Next one, a solid spherical ball rolls on a table. Ratio of its rotational kinetic energy to total kinetic energy is. So again, this is also a simple question. So what is rotational kinetic energy? There is solid spherical ball which rolls on a table. Okay. So we can say its kinetic energy of rotational motion is equal to half of half of I omega square. Okay. And I is equal to mk square, you can say. Okay. Or if you have memorized the formula for moment of inertia of a spherical object, it is equal to what? 2 by 5 mr square. So you can substitute that. So this is equal to half of 2 by 5 mr square. Okay. And r omega equals to v. So you get kinetic energy of rotational motion is 2 by 5 multiplied by mv square. Okay, sorry, half of mv square. Okay. And what is total kinetic energy? So total kinetic energy is equal to, we know it is half of mv square multiplied by 1 plus k square by r square. Okay, 1 plus k square by r square. So how much is k for a solid spherical ball? It is square root of 2 by 5. Okay, so k equals to square root of 2 by 5 r. Okay, so k square by r square will be equal to 2 by 5. Okay, so this is equal to 2 by 5, right? So you have half of mv square multiplied by what? It is 1 plus 2 by 5, that is 7 by 5. Okay, so we have rotational kinetic energy is 2 by 5 multiplied by half mv square, right? Rotational kinetic energy is 2 by 5 multiplied by half mv square, and total kinetic energy is what? It is 7 by 5 multiplied by half mv square. So this mv square, half mv square gets cancelled, 5 and 5 gets cancelled, so we are left with what? 2 by 7. Okay, so 2 by 7 is the answer, option D. Then next question, a disk is rolling, the velocity of its center of mass is vcm. Velocity of center of mass is vcm. Which one will be correct? The velocity of highest point is 2 vcm and at a point of contact is 0. Then the velocity of highest point is vcm and at a point of contact is vcm. The velocity of highest point is 2 vcm and point of contact is vcm. The velocity of highest point is 2 vcm and point of contact is 2 vcm. Which one is correct? This is a direct question. We have seen this. Option A. Very good. Okay. The velocity of highest point is 2 times velocity of center of mass and at a point of contact it is 0. Right? Let's see this next question. A solid sphere of radius r is placed on a smooth horizontal surface. A horizontal force F is applied at height h from the lowest point for the maximum acceleration of center of mass. Which is correct? H is equal to r, h is equal to 2r, h equals to 0. No relation between h and r. Okay, we have a solid sphere and it is kept on a frictionless surface. It is kept on a frictionless surface. Sorry. Now you exert some force on it at any point. Okay, you exert some force on it. F is the force, right? So now, what kind of motion will it perform? It is saying it's option D, right? So what kind of motion will it perform? It will perform sliding motion only. Okay, very good. Everybody is saying option D. right? There is no relation between H and R. Okay, because the force acting on this body will act as if it is acting on the center of mass. Okay, the external force will act as if it is acting on the center of mass, because the external force is equal to what? Mass of the body multiplied by acceleration of center of mass. Okay, so it doesn't matter at which point this external force is acting. Okay, so option is option D. No relation between H and R. Alright, next question. Consider a contact point P of a wheel on the ground which rolls on ground without slipping. Then the value of displacement of point P when wheel completes half rotation if radius of wheel is 1 meter. Okay. So consider a point of contact. Consider a contact point P of a wheel on ground which rolls on ground without slipping. Then value of displacement of point P when wheel completes half revolution. Okay, this is what we have to find out. The radius of wheel is 1 centimeter. Okay, so that is this wheel. There is this wheel and it is rolling without slipping. It's not slipping. Okay, so when when this wheel moves with half rotation, it moves with half rotation. What will happen to this point? Okay, so right now it is the point at the bottom. So when the wheel rotates, wheel completes half rotation. It will reach at the top, right? It will reach at the top. So let's suppose the wheel goes over here. Let's suppose it goes over here. Okay. So now this is the point of contact, new point of contact. So this point P, it will reach at the top. It will reach here, right? So now how much vertical distance will this point cover? The vertical distance will be 2r. Okay. And how much horizontal distance will it cover? So horizontal distance we can find out. Okay. So the it rolls without slipping. Okay. So horizontal distance will be equal to what? It should be equal to pi r. Yes or no? See, this point, let's call it Q or something. It was at the top. Okay. So if you take this much length, because this point will come at the bottom now, Q will come at the bottom. Okay. So if you take this much length, if you unwind it, let's suppose, okay, so that circumference. So if you take this circumference, if you make it straight, this much length, if you make it straight, then if you keep it over here, then you will get this length. So this is equal to pi r, and this much is equal to what? This distance is 2r. So what is displacement of this point P? So let's suppose this point is P dash. Okay. P goes from here to here. Okay. So this much would be the displacement, right? So it is equal to square root of displacement is equal to square root of, okay, uh, pi r square plus 2r square. And what is r? R is equal to 1. R is equal to 1. So it is square root of pi square, because pi times r, since r is equal to 1, okay, it is square root of pi square plus 2 square, that is 4. Okay, so this is the answer. Option or D, sorry, option B is the answer. Right, very good, Priti. So option B. A solid cylinder of mass m and radius r rolls without slipping down. Okay, an inclined plane of length L and height h What is the speed of its center of mass when the cylinder reaches its bottom? Okay, so this is a straightforward question, right? So we know V is equal to what? Square root of 2gh divided by 1 plus k square by r square. Okay, so velocity of a body when it rolls around an inclined plane, it is given by this formula. And how much is k for solid cylinder? For solid cylinder, the moment of inertia is mr square divided by 2, right? So comparing this with mk square, you get k equals to r divided by root 2, okay? Or k square equals to r square upon 2. So we can put that over here. So what do we get? We get square root of 2gh divided by 1 plus k square is equal to what? Or k square upon r square. If you take that r square on this side, k square upon r square is 1 by 2. So it is 1 plus 1 by 2. That is 3 by 2. Okay, and take that 2 in the numerator. So it will become 4, right? 2 times 2 will become 4. Okay, so you have v equals to square root of 4gh divided by 3 or 4 by 3 gh. Option C is the answer. It's very simple, right? Let's move on to next problem. A ball rolls without slipping. The radius of gyration of the ball about an axis passing through its center of mass is k. Okay, radius of gyration is k. If radius of ball be r, then the fraction of total energy associated with its rotational energy will be. Okay, so again, this is also a simple question. So, you know rotational kinetic energy. So now they are calling k as radius of gyration. So let's call kinetic energy as ke. Okay, so ke rotational is equal to half of I omega square. We know this. Okay, and if you know radius of gyration, what is I? I is equal to mk square. Okay, so we have half of mk square omega square. Okay, it is rotational kinetic energy. Then what is total kinetic energy? So we want ratio of this rotational kinetic energy to total kinetic energy. So Ke rotational plus Ke translational, right? So it is what? Half of mk square omega square plus half of mv square. Okay, mv square. And for a body which is rolling without slipping, we know that v is equal to v is equal to r omega, right? So v square is r square omega square. So we can put that over here. Okay, so in place of v square, we can put r square omega square. And then we can take half of m omega square common and we can cancel it out in these three terms, right? We can take it common and cancel it out. So what is left? So it's equal to k square divided by k square plus r square. And that is the answer. Option C is the answer. Okay, so let's see next question. And this is conceptual question. So I expect answer from you. A drum of radius r and mass m rolls down without slipping along an inclined plane of angle theta. Okay, so there is a drum which rolls down an inclined plane. The frictional force, option A, dissipates energy as heat. Option B, decreases the rotational motion. Option C, decreases the rotational and translational motion. And option D, converts translational energy to rotational energy. So without friction, you cannot have rolling motion, right? Okay, so this option is correct. Okay, if there is no friction, the body will just slide down. Okay, it will not roll at all. There will be no rotational motion. Okay, so option D is correct. Right, very good. Let's see next question. A solid cylinder and a hollow cylinder, both of the same mass and same external diameter, are released from the same height at the same time on an inclined plane. Okay, a solid cylinder and a hollow cylinder. Both have same mass, same external diameter. That means radius is same. They are released at the same time. Okay, on an inclined plane. Both roll down without slipping. Which one will reach the bottom first? This is the question. Which one will reach the bottom first? So tell me. Okay. We know T is equal to what? Square root of 2 times S divided by acceleration. And what is acceleration in rolling motion? It is g sine theta divided by 1 plus k square by r square. But that 1 plus k square by r square is in denominator of denominator. So it goes into the numerator. Right? So if k is more, time taken will be more. Okay. So what is k for solid cylinder? So k for solid cylinder is r upon root 2, and k for hollow cylinder is just r, because moment of inertia of solid cylinder is mr square by 2, and moment of inertia of hollow cylinder is just mr square, right? So what is the answer for solid cylinder? Okay, k is r upon root 2. That means k is smaller. Okay, for hollow cylinder, k is equal to r. Okay, so solid cylinder will take less time, because see, okay, it depends on k. If k is more, time taken will be more. So k for hollow cylinder, okay, k for hollow cylinder is greater than k for solid cylinder. That means time taken by hollow cylinder will be more than time taken by solid cylinder. So solid cylinder will reach first. So a solid cylinder of mass 3 kg is rolling on a horizontal surface with velocity 4 meters per second. It collides with a horizontal spring of force constant 200 newtons per meter. The maximum compression produced in the spring will be. So see what's happening. There is a solid cylinder. Okay, this is a solid cylinder. It rolls on horizontal surface. Okay, it rolls on this horizontal surface, and there is a spring. There is the spring, okay, which might be connected to some rigid support like this. So the cylinder, it rolls down and it compresses that spring. Okay, so there is some compression in the spring. So till what time that compression will go on? When when will it stop compressing? When the total kinetic energy of this cylinder gets converted to what? The potential energy of spring, right? At that point it will stop. Okay, so I can say kinetic energy of the cylinder is equal to potential energy of spring. Okay, so how much is kinetic energy of this rolling cylinder? It's half of mv square multiplied by 1 plus k square by r square, and potential energy of spring is half of k into x square, right? This k and this k is different. So this small k is spring constant, this capital K is, it is radius of gyration. Okay, so half and half is cancelled. We want x, right? So we can take k on the other side. Okay, or let's substitute the values. So what are the values? Mass is 3 kg. Okay, velocity is 4 meters per second. So 3 multiplied by 4 square multiplied by 1 plus k square by r square. So it is solid cylinder. how much is k for solid cylinder? It is 1 by root 2, right? So k square upon r square will be 1 upon 2. Okay, so 1 upon 2. This is equal to k times x square. So how much is k? K is 200, right? 200 times x square. So this is 1 plus 1 by 2, 3 by 2. Okay. Now, right. So it is 3 by 2. Okay. So 3 multiplied by 4 square. Okay. Multiplied by you have 3 by 2 and that 200 also. We can take it on this side. So multiplied by 200 is equal to x square. Okay. So 2 times 2 is 4. So it will cancel out with one of the 4 of this 4 square. Okay. So we have 3 square times 4. Okay. 3 square multiplied by 2 square we can say. Or okay. It is 9 times 4, 36 multiplied by 10 raised to minus 2 because there is this 100 in denominator. Okay. So this is equal to x square. We want x. So it is square root of that. So it is 6 multiplied by 10 raised to minus 1. Okay. That is 0.6 meters. Option B. Then let's see this next question. A small object of uniform density rolls up a curved surface with an initial velocity v. Okay. It reaches up to maximum height of 3v square upon 4g with respect to initial position. The object is. Okay. So there is a small object which rolls up curved surface with initial velocity v. Okay. So there will be some rolling kinetic energy. So when it reaches the maximum height, what will happen? The kinetic energy will get converted to potential energy. So we can say kinetic energy at start or kinetic energy at bottom is equal to potential energy at top. Okay. So that is half of mv square multiplied by 1 plus k square by r square. The similar kind of question only. It is equal to mgh, right? So m and m gets cancelled. Then it is half of v square multiplied by 1 plus k square by r square. So this is equal to g multiplied by h, and they have given that it reaches to this maximum height 3v square divided by 4g. So we can substitute that. So multiplied by 3v square upon 4g. So g and g gets cancelled, v square and v square gets cancelled out, right? So 3 by 4 is equal to half of 1 plus k square by r square. That means if we divide this 4 by 2, it's 3 by 2. So 1 plus k square by r square is equal to 3 by 2. That means k square upon r square is equal to 3 by 2 minus 1. That's half. Okay. So k upon r is equal to 1 upon root 2, or k is equal to, we can say, r upon root 2. Okay. So can you guess which is that object? Can you guess the object? Is it option D? It is option B. Okay. It's a disk. So it's very important to remember moment of inertia, right? Mm, Without that, we can't solve questions. Okay, next question. Ratio, sorry, the ratio of accelerations for solid sphere of mass m and radius r rolling down an incline of angle theta without slipping, and slipping down the incline without rolling, that means sliding down only, okay, is. So when it slides down, it's a solid sphere. When it just slides down, how much is acceleration? So for any body which slides down, okay, acceleration is what? G sine theta, right? Acceleration is G sine theta. So we want ratio of acceleration uh, rolling down without slipping. We want first rolling down without slipping, two slipping down without rolling. Okay, so we want acceleration of rolling, the ratio of acceleration of rolling to acceleration of sliding. Okay, so that is G sine theta divided by 1 plus k square by r square, and this divided by G sine theta. Okay, G sine theta. So G sine theta and G sine theta will get cancelled out. Okay, so what is k square by r square? So it's a solid sphere. So for a solid sphere, k is equal to what? Root 2 by 5 r, because moment of inertia is 2 by 5 mr square, right? So k square by r square is 2 by 5. Okay, so this is 1 upon 1 plus 2 by 5, or it is, you can say it's 1 upon 7 by 5. So take that 5 to the numerator. It's 5 is to 7. Okay, it is 5 is to 7. Option A, right? A disk and a sphere of same radius but different masses roll down on two inclined planes of the same altitude and length. Which one of two objects gets to the bottom of the plane first? Okay, so this is repeated question. Both reach at the same time, depends on their masses, disk or the sphere. Which one? Right. So we know the time taken is equal to what? Square root of 2 times s divided by acceleration, which is g sine theta, and divided by 1 plus k square by r square. So that goes to numerator. Okay. So if if k is more, t will be more. Okay. So k for disk is what? R divided by root 2. And k for sphere is root 2 by 5. Root 2 by 5 r. Okay. So which one is more? 1 upon root 2 or root 2 by 5? So we can do square and find it out, right? Because we want square only. Okay. So 1 upon 2. So square of this will be what? 1 upon 2. Okay. And square of root 2 by 5 will be 2 by 5. So which one is more and which one is lesser? This one is 2 by 4. This one is 2 by 5. So this is smaller, right? So k for sphere is smaller. Okay. So it will reach earlier. Option D is the answer. A solid sphere is rolling. A solid sphere is in rolling motion. In rolling motion, a body possesses translational kinetic energy kT as well as rotational kinetic energy kr simultaneously. The ratio of kT divided by kT plus kr for the sphere is. So again, this is also simple. Okay. So what is translational kinetic energy? So kT is equal to half of mv square, or you can say for a body in rolling motion, because it is in rolling motion, it is half of v is equal to what? R omega. Okay. So it is half of m multiplied by r square omega square. And what is rotational kinetic energy? So it is half of I omega square. Okay. So we want kT divided by kT plus kr, rotational kinetic energy. Okay, so that's equal to half of mr square omega square plus half of mk square omega square. Okay, so we can cancel out this m omega square and half. So what's left? R square divided by r square plus k square. Okay, and how much is k? So we can take r square common and cancel it out. So what do we get? So we can take r square common and cancel it out. So what will be left here? 1 plus k square by r square. Okay, and how much is k for solid sphere? It's 2 by 5. Right, k is equal to 2 by 5. Sorry, k square will be equal to what? 2 by 5 r square, because k is equal to root 2 by 5 r. Okay, so we can substitute that. So this is 1 upon 1 plus 2 by 5, or it is 1 upon 7 by 5. Okay, so it is 5 by 7. Right, 5 by 7. Option B is the answer. Solid cylinder of mass 2 kg and radius 50 centimeter rolls up an inclined plane of inclination 30 degree. The center of mass of cylinder has speed of 4 meters per second. The distance traveled by cylinder on inclined surface will be. Okay, so that is a solid cylinder of mass 2 kg and radius 50 centimeter rolls up an inclined plane. Okay, and question is the distance traveled by cylinder on the inclined surface will be. So till what height? Not till the height. So what is the distance traveled? Okay, this is the question, right? So till what point will it go? Kinetic energy at bottom is equal to potential energy at top, right? Either you can solve it this way, or you can solve it this way, that final velocity is equal to what? Final velocities will be equal to what? It is 0. So v square equals to u square plus 2 times as, right? So this is 0. U is given. Okay. So u square plus 2 times a. What is acceleration? So if it is rolling down, then acceleration is g sine theta divided by 1 plus k square by r square. Now it is going up, rolling up. So acceleration will be negative, right? So acceleration will be negative. So I can put minus sign, and this is g sine theta divided by 1 plus k square upon r square multiplied by s. And s is what we have to find out, right? So we can take this on left hand side. So it is 2g sine theta upon 1 plus k square by r square multiplied by s is equal to u square. Okay, and therefore s is equal to u square multiplied by 1 plus k square by r square upon 2g sine theta, right? So now we have to substitute the values, and now we can substitute the values. Okay, so this is equal to, how much is u? U is 4 meters per second. Okay, 4 square multiplied by 1 plus k square by r square. So it's a cylinder. How much is radius of gyration? 1 upon root 2 times r. Okay, so k square by r square is 1 by 2. So 1 plus 1 by 2, that's 3 by 2, divided by 2 times g is 10, and theta is how much? 30 degrees. Okay, so sine of 30, which is 1 by 2. Right? So you have 1 by 2 there. So this is equal to 4 square So this 2 and 1 by 2 gets cancelled. So 4 square is 16. Okay, it's 16 multiplied by 3 by 2 and divided by 10. So you can say, yeah, so divided by 10. So 16 by 2 is 8, 8 3s are 24, 24 divided by 10 is 2.4. Okay, 2.4 meters is the answer. Okay, a disk of radius 2 meter and mass 100 kg rolls on a horizontal floor. Its center of mass has speed of 20 centimeters per second. How much work is needed to stop it? So this is simple. Whatever is its kinetic energy, same amount of work will be needed to stop it. Okay, so work needed is equal to its kinetic energy of rolling motion. So it is half of mv square 1 plus k square by r square. We just have to substitute the values. Okay, so it is half of mass is 2. No, mass is 100. Sorry. Mass is 100, radius is 2, and the speed is 20 centimeters per second. So let's convert this to meters per second. Okay, it is 0.2 meters per second, right? 20 centimeters per second. So 0.2 square multiplied by 1 plus k square by r square. So that is, because it's a disk, k is equal to what? R upon root 2. So k square by r square is 1 upon root 2. So 1 plus k square by r square is 3 by 2. Okay. So we have 0.2 square will be equal to 0.04. 0.04 multiplied by 100. So that will give you 4. Okay. Multiplied by 3 divided by 2 times 2 is 4. So that 4 and this 4 gets cancelled out. So option is 3. Okay. 3 joules is the required work. So this one is from Neet 2017. Which of the following statements are correct? Center of mass of a body always coincides with the center of gravity of the body. Is it correct? Is it true? No. Good. Center of mass of a body is a point at which the total gravitational torque of body is zero. It's not true. It is center of gravity. Right. Next one, a couple on a body produces both translational and rotational motion in body. Not true. Okay, it produces only the rotational effect. Okay, and last one, mechanical advantage greater than 1 means that small effort can be used to lift a large load. Okay, so this one is correct, not option D. Option 4 is correct. And actually none of these options is correct, only fourth is correct. Okay, so this is the mistake. So let's see next question. A rod of weight W is supported by two parallel knife edges A and B and is in equilibrium in the horizontal position. It is in equilibrium in horizontal position. The knives are at distance D from each other. The center of mass of the rod is at distance x from A. The normal reaction on A is. Okay. So this is very simple question. There is a rod of weight W. Okay. And it will have some length. Now its weight will act downwards. From which point? From the center of gravity. Right? From the center of gravity. And because this is symmetric body, it will act downwards from its midpoint only. Now you are using two knife edges at A and B. So let's suppose this is point A and this is point B. You are using two knife edges to support it. So they will exert some normal reactions which will be vertically upwards. Okay. So let's suppose normal reaction due to the first one is N1, normal reaction due to the second one is N2. Okay. So this normal reaction due to the first one is suppose N1, normal reaction due to the second one is N2. This is N1, this is N2. Okay. So now the distance between A and B, that is two knives, is D. Okay, that distance is D. Right, this distance is D. It's given. And the center of mass of the rod is at distance x from A. Okay, so we don't know whether it's symmetric or not. Okay, if rod is symmetric, then it will act at the midpoint. Okay, so this distance is given, this distance is x, right? So how much would be this distance? This distance will be equal to what? D minus x. This distance will be equal to D minus x. Okay, so now what we can do is we have to find out normal reaction on A. So we want to find out N1. Okay, we want to find out N1. Now short trick here is to take moments of forces about the second point because we don't need N2, right? So for rotational equilibrium, what do you need? Torque due to W and torque due to N1 should be balanced. Okay, so let's take torque due to all the forces about point B. Okay, they are equal to. So how much is distance of W? It is D minus, sorry, it is D minus X, right? So D minus X multiplied by W multiplied by sine of 90, which is 1. Okay, and this rotation, you can see this rotation is in which sense? So W is towards left, right? It is, I mean, W is on the left side of this point B. Okay, so this is the position vector, this is W, so R cross F. So this W will rotate the rod in anti-clockwise sense. Okay, see the other one, other torque. So other torque is due to this knife, okay, which is N1 at A, right? So sorry, the normal reaction is N1, which is at distance D from point B. And in what direction? It is rotating the body. So this is upwards and this is, see, the position vector is towards left. Okay, so this is R and this is F. So R cross F, it is rotating the body in clockwise sense, right? This is clockwise sense. So if we take anti-clockwise rotation as positive, then clockwise would be negative. Okay, the clockwise would be negative. So minus, how much is distance of this force from point B? It is D. D multiplied by this force is N1, right? And this torque must be equal to 0 if the body is balanced. So now we can take this D times N1 on other side. So we get D times N1 is equal to D minus X times W, and we want N1 only. So it is N1 is just equal to D minus X divided by D times W. Okay, so option B is the answer. Yeah. So this question is repeated in 1998, 2012. ABC is an equilateral triangle with O as its center. O is the center. F1, F2, F3 represent three forces acting on the sides AB, BC and AC respectively. If the total torque about O is 0, then the magnitude of F3 is. So total torque is 0, right? How much is F3 is the question. So see, let's find out total torque. So this F1 is at some distance from the from what? The center, actually centroid. Okay, so it is at some distance. F2 and F3 are also at the same distance. Okay, but now see, the action of force is different. So if you take this as its position vector, so now F1 is rotating this triangle in anti-clockwise sense. You can see this is R, this is F1. So R cross F, if you take, it is rotating the triangle in anti-clockwise sense, right? What about F2? So F2 is also rotating the triangle in anti-clockwise sense. Okay, it is also rotating the triangle in anti-clockwise sense. And what about F3? So let's draw its position vector. It will be like this. So if you take R cross F, this is R, R3, you can say R3 cross F, it is rotating the body in clockwise sense. Okay, they are at the same distance. They are at the same distance. Okay, so if you can think this way, or you can say this angle is theta, this angle is theta. How much will be this angle, by the way? This will be 30 degrees, right? So this will be angle bisector. This angle is 60, so this is 30, so this angle will be 30 degrees, right? So angle between R1 and F1 is 30 degrees. Angle between R2 and F2 is also 30 degrees, but angle between R3 and F3 is not 30 degrees. It is 180 minus 30, right? It's 180 minus 30. So you can say tau 1 plus tau 2 plus tau 3 is equal to 0. Okay, so how much is tau 1? It is it is R1 into F1 multiplied by sine of 30 degrees, okay, plus R2 F2 multiplied by sine of 30 degrees plus R3 F3 multiplied by sine of 150 degrees. This is equal to 0. And sine of 150 is minus sine 30. Okay, so this is the rule. Sine of 180 minus theta is equal to minus sine theta, right? Sine of 180 minus 30 is sine of 150 is sine of 180 minus 30. So it is equal to minus sine 30. Okay, so we can take sine 30 common and we can cancel it out. So, and also R1 is equal to R2 is equal to R3, right? So we can take that also common and cancel it out. So we have F1 plus F2 minus F3 is equal to 0, or you can say F1 F3 is equal to F1 plus F2. Okay, F3 is equal to F1 plus F2. Option A. This is simplest question. Couple produces. Couple produces what? Linear and rotational motion, no motion, purely linear motion, purely rotational motion. Right. Option D. Purely rotational motion. Next question. This is from Neet 2013. A rod PQ of mass m and length L is hinged at P. So here is P. The rod is kept horizontal. It is kept horizontal by a massless string tied to point Q. So it is kept horizontal. Okay, it is hinged at this point, and it is connected to the string, massless string. Okay, and because of that it is horizontal. So when string is cut, the initial angular acceleration of the rod is. So if you cut the string, what will happen? There will be some angular acceleration. So see, this is a rod, suppose it is hinged at this point. It is free to rotate about this point, but it is held at this point. Okay, so it will not fall from this point, right? But it can rotate, and now you are supporting it by means of this thread or a string at the other point. If you release it from there, what will happen? It will rotate like this. Okay, so the rod rotates like this. It rotates like this. So what will be its initial angular acceleration? Okay, angular acceleration at starting point. This is the question, which is very simple. See, so when you cut this string is cut. Now, what are the forces acting on it? So it is hinged at this point. Okay, so there is only one force, which is the gravitational force, and which will act from the center of gravity. Okay, L by 2 of the rod, right? And therefore, how much would be the torque? So torque is equal to L by 2 multiplied by its weight. So its mass is m. So weight will be equal to what? M multiplied by g, right? This much is torque, and we want angular acceleration. So torque is also equal to I multiplied by alpha. Okay. So it will rotate about this point, right? It will rotate about this point. Okay, point P. So torque is also equal to what? I multiplied by alpha. I is the moment of inertia. Now we have to use correct formula for moment of inertia. There is one formula, ml square upon 12. Okay, which is about an axis which passes through the center. We don't want that. We want a formula for moment of inertia about this axis which passes through what? One of its edges. So what is that formula? I is equal to what? Okay, so first of all I will equate this. I alpha equals to, because this is torque is I alpha, it's equal to what? L by 2 multiplied by mg. So what is formula for moment of inertia for uh, for a rod for the axis which passes through its edge? It is ml square by 3. Okay, it is equal to ml square divided by 3. So ml square by 3 multiplied by L alpha is L by 2 multiplied by mg. So m gets cancelled. Then what else? L gets cancelled with this one. Okay, one L will be left here, and that you can move on the other side. This 3 you can move on the other side. So alpha equals to 3 will go to the numerator, 3 by 2 g upon L. Okay, option C is the answer. Right, option C. Very good. A uniform rod AB of length L and mass m is free to rotate about point A. So this is uniform rod. It is free to rotate about this point. The rod is released from rest in horizontal position. So again you are releasing that rod from the horizontal position. Given that the moment of inertia of the rod about A is ml square by 3. Here moment of inertia is also given. The initial angular acceleration of the rod will be. This is same question, right? This is same question. So I alpha equals to what? The torque. Okay, tau equals to I alpha. So how much is the torque? Torque is equal to, so there is this gravitational force acting on it, okay, mg, and it acts at distance L by 2 from A. So torque is L by 2 multiplied by mg. and I is given, I is ml square by 3. Okay, so gets cancelled, L gets cancelled, and the answer would be what? This is same question actually, the last question. Okay, so option B here, B or C? Option C. Okay, so alpha is 3 by 2 G upon L, right? A uniform horizontal meter scale of mass m is suspended by two vertical strings attached to its two ends. A body of mass 2m is placed on 75 centimeter mark. The tension in the two strings are in the ratio is. Okay, so there are two strings. There is a horizontal meter scale. Its mass is m and it is suspended by two strings. So there will be some tension in first string T1, tension in second string T2. Okay, a mass of 2m is placed at 75 centimeters. So 75, so let's suppose this is midpoint O. So 75 means it is at distance of, okay, 3/4 of the length, we can say, right? So this mass is 2 times m into g, we can say, is the weight acting downwards. Okay, the tension in the two strings are in the ratio, right? So then there will be weight of this meter scale acting downwards from this point. So it is mg. Okay, so we need to take talks about some point. Okay, so first of all, we can have two conditions here. So these two tensions should support the total weight. These two tensions should support the total weight. So total weight is how much? Mg plus 2 mg, 3 mg. Okay, so T1, I can say, from the translational equilibrium, you have T1 plus T2 equals to mg, this mg plus 2 mg, 3 mg. Let's call this equation number 1. Okay, and then let's call this point A, this point B. So now let's take moments about point A. Okay, taking moments about point A. Okay, so why am I choosing point A? Because I don't want actually two equations, two simultaneous equations. Okay, I mean, I don't want two equations in terms of T1 and T2. So I'm getting rid of T1 if I take moments about point A. Okay, so this distance is L by 2, or you can say 50 centimeters. So moments about point A, how much will be moment due to this mg? It will be 50 centimeters multiplied by mg, right? In what direction? So this is, okay, it's position vector, and this is the force. So r cross f, it is in clockwise sense. Okay, this force is also downwards. Its position vector is like this. So r cross f, this is also in clockwise sense. So plus, you can say 75 multiplied by 2 mg, right? And this force is upwards. So r cross f, it is in anti-clockwise sense. See its position vector for this force T2. Okay, it is at point B. It is like this, and force is like this. R cross F is in anti-clockwise sense. So its sign will be negative. So minus 100 multiplied by T2, and sum of all moments should be equal to what? 0. Okay, the body is in rotational equilibrium, right? So we can say that 100 T2 is equal to 50 mg plus how much is this? 75 times 2, 150. Okay, so 50 plus 150, 200. 200 mg, and therefore we can say T2 is equal to what? It is just 2 mg. Okay, and since T1 plus T2 is 3 mg, T1 would be equal to 1 mg. Okay, so 1 mg and T2 is 2 mg. What's the ratio? 1 is to 2 is the ratio. A meter stick is balanced on an eye page. No, this is different. A a meter stick is balanced on an eye page. At its center, two coins, each of mass 5 grams, are put one on top of the other at 12 centimeter mark. The stick is found to be balanced at 45 centimeters. What is mass of the meter stick? Okay, so there is this meter stick, right? And what are you doing is you are putting two coins. You are keeping two coins one on top of the other like this. At what mark? So this much distance is 12 centimeters. So if you do so, what happens? You can balance it at, they are saying, at the 45 centimeters. Let's use different color. So you can balance this meter scale at 45 centimeters here. Okay, so this much distance is 45 centimeters, right? What is the mass of the meter scale? So its weight will act downwards from the midpoint, from 50 centimeters. Okay, so this is mg, sorry, mg. Okay, and then you are balancing it about this point, right? So let's call this point something. Let's call this point O, or let's call it A only. Okay, this is B and this point is C, right? So these weights you are keeping at point B. Okay, these two coins you are keeping at point, sorry, this point is B. Okay, so now let's take moments about A, because we are balancing them about A. So let's take moments about A. So taking moments about point A. So we get rid of this force needed to balance. Okay, so these two weights, or this weight of two coins, it will act downwards. And how much is that? It is 10 times G. Okay, 10 grams times G, because weight of mass of one coin is 5 grams. So mass of two coins is 10 grams. So weight is 10 times the acceleration due to gravity. Okay, how much would be this distance? So from here to here it is 45. This distance is 12. So this distance would be equal to what? 45 minus 12. That is 33 centimeters. Okay. So how much is torque due to these coins? So it is 33 multiplied by 33 is distance. Okay. So distance multiplied by 10 g. This is torque due to coins. And in what direction it is acting? So this is okay. This is the position vector. Okay. This is the position vector, and position vector is directed like this. This is the weight. So r cross f, if you take, it is in anti-clockwise sense. For the other force, that is for the weight of this, weight of the meter stick, it is r cross f, it is in clockwise sense. Okay, so this is position vector. Okay, it's directed in this direction. R cross f is in clockwise sense. I mean, rotation is in clockwise sense. If you take r cross f, it will be what? So it will be into the plane of that screen. Okay, but rotation is in clockwise sense. So we'll take negative sign for that. And how much is that distance? Distance AC. So the weight acts downwards from 50 centimeters and you are balancing it at 45. So this much distance is 5. So minus 5 multiplied by mg is equal to 0 because it is balanced. Okay, so torque, sum of all torques must be equal to 0 and therefore we get 5 mg is equal to 33 multiplied by 10 times g. G and g is cancelled. Okay, so we can divide that by 5, the other side. So 10 divided by 5 is 2. 2 times 33 is 66. So m is equal to 66 and it is in grams. Okay, this is grams. It's not g. Okay, this is in grams. Option B is the answer. Let's see another one. Two children weighing 30 kg and 45 kg wanted to balance a seesaw up laying 4 meter pivoted at its midpoint. A child of 30 kg is sitting at one edge of the seesaw. The distance at which the other child sits so that the seesaw is exactly balanced is. Okay, so seesaw has length of 4 meters. So seesaw, this is suppose seesaw, sorry. Okay, one child sits here. Okay, exactly at one end, and his weight will act downwards from that end. Okay, how much is that? So its mass is 30 kg. Let's call it m1. So m1 times g is the weight. Okay, the other child, let's suppose sits over here because that other child is heavier one. He will sit at closer distance. Okay, remember mechanical advantage. Okay, so it is m2 times g. So torque due to the first child will be in, I mean, it will rotate the seesaw in anti-clockwise sense, and due to the second child, it will rotate the seesaw in clockwise sense. So if we take torques about this midpoint, so we can say that L by 2 multiplied by m1g minus x multiplied by m2g is equal to 0 because torque due to this first force is in anti-clockwise sense, it is rotating the body in anti-clockwise sense, and torque due to the second force is rotating the body in clockwise sense. Okay, so that's why the second one is negative, and therefore x times m2g, or we can cancel out g and g, so we can say x times m2 is equal to what? L by 2 times m1, and we can take m2 on other side, so x is equal to L by 2 multiplied by m1 divided by m2, and that is equal to how much is L? So L is 4, so 4 by 2 multiplied by m1 is 30, m2 is 45, so 30 upon 45 is 2 by 3. Okay, so that 2 and 2 gets cancelled, right? So it is 30 divided by 45 is 2 is to 3, 2 and 2 gets cancelled, 4 upon 3, so 1.33. What? This 2 2, I'm sorry, I'm doing some mistake. 1.33 meters, right. Option, yeah, option 1, 1.33 meters. Okay, is it clear? Let's see this one more question. If street light of mass m is suspended from the end of uniform rod of length L in different possible patterns as shown in the figure. Now, pattern A is more sturdy. This is pattern A, pattern B, pattern C. So cable is okay. Cable is connected to this point. In pattern B, cable is connected to this point. In pattern C, it is connected to this point. So point at which it is suspended from the cable, it is different. Okay. So this total distance is L. This is, it's given, it is 3L by 4, and here it is L by 2. So pattern A is more sturdy, pattern B is more sturdy, pattern C is more sturdy. All will have same sturdiness, which is the answer. Why so? So if you take torque about this point, okay, if you take torque about this point, so now the street lamp, it is connected at same point in this diagram, in this one and this one, in all three patterns. Okay, so you have to exert some torque, right? So now, if distance of this if distance of this cable is more, then the tension in the cable will be less. Okay, if cable is closer, then you have to exert more tension, right? Remember the mechanical advantage, load arm and the effort arm. Okay, so here, if distance is more, the tension in the cable will be lesser, and that's why it will be more sturdier. Yes, no? Okay, good. So this is the answer. Pattern A is more sturdy. Okay.